All right, guys. So do you all know how to factorize? That's one of the first things I want to look at. Do you all know how to factorize? Yes or no?
Yes, sir.
All right. So the most common type of factorization is like the greatest common factor. So let me show you guys what I'm talking about. Let's just say, for instance, you had, say, 70x squared plus 9x. Actually, it's 35x. Tell me, guys, is there anything in common between 70x squared and 35x?
Divisible by 5.
Divisible by 5, yeah. And are you seeing anything else in common with x squared and x?
The x
Both have
value.
an X.
Yes. Now, what is the greatest common factor? Actually, I'll write it out so you can see it. It's possible for me to write 70 as 35 by 2. Yes or no? Could I write 70 as 35 by 2? Tell me. Tell me, guys. Could I do that?
It would have to be 2X.
It'll be 35 by 2 multiplied by x multiplied by x. I'm just writing out, I'm just writing it out as a product. So, guys, can we all agree that 70 is the same thing as 35 by 2? Yes or no?
Yes, sir.
What about the rest of you guys? Guys, do you all know that 35 at 70 is the same thing as 35 by 2?
Yeah.
Okay. And do you all know what x squared means? Let me know. Do you all know what x squared means? If you don't know, that's fine. Tell me. Talk to me. Right. So if you see x to the power 2, it means x by itself. So x multiplied by x. Guys, if I ask you what 5 squared was, what would you tell me? What is 5 squared?
5 by 5?
Exactly, 5 by 5. Because 5 squared is 25. It's the same concept with x squared. X squared is x by x. So 70x squared is the same thing as 35 by 2 by x by x. Am I confusing you all with this? Like, is this, like, do you all understand how I wrote that up? You'll see where I'm going with this. And I could write 35x as 35 multiplied by what? 35x is 35 multiplied by what?
35 multiplied by 2.
No, 35 by x. Because what?
35.
We have
35x.
35x. We have 35x. That means 35 multiplied by x.
Yeah.
So check this out, guys. Is there anything common between this term and this term?
Well, they both have X, so we
Don't
could
they
put on
both
the X.
And they both have 35.
35, yeah.
So if I were to factor out the 35, I'm going to write 2. Oh, and they also have x, right? So I have to pull out that x. So if I pull out the 35 from here and I pull out one of the x's, what am I going to write inside?
You're gonna put the 2 and you're gonna put the X
Right? 2x. And
plus
what
1.
plus 1? Yeah. Now let me explain what's happening over here, right? So whenever we factor out the greatest common factor, I want to pull out the greatest thing that both of them have in common. So if you look at this, guys, it's x squared over here. So how much x's does this have in it?
2.
Yes, that has two x's. How much x's does this have? It's just x. It's just
1.
right. So x squared means x by x. So what is the greatest common amount of x's you see in here? You can't say two, right? Because guys, do both of them have two in common? Or do both of them just have one x in common?
1x.
Exactly. So I'm going to factor out the x. And when I wrote it as a multiple, you would have seen what I'm talking about. So 70x squared is the same thing as 35 by 2 by x by x. So you're multiplying x by itself here. Over here now is 35x. So that's just 35 by x. So as you can see, we're multiplying x by itself 2 times here. Over here, you're just multiplying it by itself 1 time. It's just x. So as you can see, what do we have in common between both of them? Well, we have 35 and we also have an x. So I pull out the 35x. If I pull out the 35x from over here, I'm going to be left with 2x. And if I pull out the 35x from here, it's going to be 1. And you might be confused. So let me explain something. Now, whenever you factorize something, when you expand it out, you're supposed to get back the original answer you started with. So guys, my question is, what is 35x by 1? What is 35x by 1? Do you know what so what is any
35x.
If I ask you what is 7 by 1, what would you tell me? 7 by 1 is what?
7.
Exactly. So 35x by 1 is?
35x.
Exactly. So you see, we get back to 35x. And what would 35x by 2x be?
70x squared.
Right, because what's 35 by 2?
70.
And what is x by x?
X squared.
Exactly. So let's run through it back one more time. So when you look at this, right? When we look at this, what is the greatest thing that 70x squared and 35x have in common? Both of them are divisible by
5.
By 35.
35. Don't just say 5, because if I say 5, I can still factor out more terms. I want to pull out the greatest common factor, right? So 35. And what is the greatest common factor between x squared and x?
X.
Exactly, x. I can't say 2x's because there isn't 2x's over here. So I can't do that. And again, when you multiply it out, you're supposed to get back the original thing. So if you have trust issues, you can multiply it out quickly. So 35x by 2x, that's going to be 70x squared. And 35x by 1 is going to give you back 35x. So guys, can we see how we got back the original thing? Let me know.
Yeah.
Yeah?
Yes, sir.
Let's do some couple more examples because they love to bring this in CX. Factorization by the greatest common factor. All right. And of course, if at any point in time you feel confused, just tell me, right? So I realize I start off a bit complex. So let's tone it down a little bit. Let's just say we had 5x plus 5. What do you suppose 5x and 5 has in common?
5.
5, right? By the way, we have a special guest. Check Froggy. All right, so we have 5 in common. So you know what? If I pull out that 5, what do you think I'm going to write? Well, let's see. What would I have to write inside here so that when it multiplies, it gives me back 5x? What by 5 is 5x?
X plus 1.
Right? So the final answer would be x plus 1. And let's try to understand why. If I multiply 5 by x, what is 5 by x? Tell me, guys, what is 5 by x?
5x.
And what is 5 by 1?
5.
Exactly. So do we get back the original thing?
Yeah.
Yeah, we do. Faith, let's look at an example together. So what about 3a plus 6? Right? So Faith, what is 3a and 6 both divisible by?
3.
3. So if I pull out 3, what by 3 would give me back 3a?
You're paying A plus 2.
All right. Are you all okay with these simple examples? Example 2 and 3? Let me,
Yes, sir.
okay, I'm going to step things up a notch now. So what about 4x squared plus 8x? In this instance, guys, first of all, what is the greatest common factor between 4 and 8? What's the biggest number that can go into 4 and 8? 4. And if you have x squared here, that would mean x by x. And this is just x over here. What is the greatest thing in common between x by x and x? How much x is?
X, 1x.
X. So we are going to pull out our x, right? And now I'm going to ask you, what by 4x would give me back 4x squared?
1x
Right? Just write x. And my other question, guys, what by 4x would give me back 8x?
plus 2.
Plus 2. And that's how you factorize using the greatest common factor method. You look for the largest number that both of the terms are divisible by, and you pull that out. And a way to check if your answer is correct, when you distribute this term on the outside to all the terms on the insides, you are supposed to get back what you started with. So guys, as you can see, 4x by x. What's that, guys? What's 4x by x?
4x squared.
What is 4x by 2?
8x.
8x. Guys, do we understand that? Let me know.
Yes.
Right, so I want to volunteer Danelle, did it? Danelle, let me know if you're there.
Yes, sir.
So Danelle, let's look at our question together, right? I'm gonna raise these stakes a bit.
Of course.
What if we had 6y cubed minus 12y squared? Now, first things first, right? What is the greatest common factor between 6 and 12?
6.
6. Okay, that's good. If you have y cubed, that means you're multiplying y by itself 3 times, right? Did you know that?
Yes, sir.
And if you have y squared, that means you're multiplying y by itself 2 times. So
Yes, sir.
what is the greatest common, okay, what is the greatest amount of y's you see in common in both?
2. Y2.
Right? So if it's y by y, that'll be 2y's, right? So y squared.
Okay, Y
So that would
squared.
be 6y squared. Did that confuse you?
No, sir.
Okay. And if I pull out 6y squared from 6y cubed, that would have meant that I pulled out 2 of the 3 y's. So
Yes, sir.
what am I going to write here?
1Y.
Mhm.
Um, minus
Minus.
6Y.
Nah.
2Y.
Yes. Because what by 6 would give you back 12?
6 twos.
2, right? And you want to get back negative 12. So positive 6, right? You
Okay.
multiply a positive number by a negative number to get back a
A negative number, too.
right. And if you guys forgot, let's just run through back the basic science you need to be familiar with. So if you have a positive multiplied by a positive, what do you think you're going to get?
A positive.
Right? What about a negative by a negative?
A negative. No, a positive.
Positive. What do you think a positive by a negative would give you?
A negative.
What do you think a negative by a positive would give you?
A negative.
So please keep this in mind, right? So check this. If I want to get back negative 12, right? Forget about the sign for now. What by 6 is 12? What by 6 is 12?
2.
2. I want you to put on a 2, right? And then I want you to ask yourself, all right, I want to get back negative 12. Over here, we have positive 6. I must multiply a positive by a what to get back a negative? A positive by a
Negative.
right. So in doing that, you end up with y minus 2. Let me know if that confuses you or if you understand the general concept.
No, I understand, sir.
Okay, great. Right, so I need a volunteer. So 7p squared q, right, minus 14pq.
Maybe don't say -2, maybe say -2. because you might think that you're adding, like up here is positive 2 and down here is negative 2, because that used to confuse me.
Okay. Right, so -2. So, Faith, let me ask you a question. What's the greatest common factor between 7p squared q and 14pq?
7.
7, right? And let me ask you a question. Over here, how much times are you multiplying p by itself?
Twice.
Twice. So p by p, and over here, it's just p.
Yeah.
So
1p.
exactly 1p, right? Because that's what is in common between 7p squared q and 14pq. So I'm going to pull out p. Are you seeing a q here and a q here?
Yeah.
Right, so we could pull out the q as well. So what by 7pq would give me back 7p squared q? Now we already have a 7, we already have a q, and we have 1p. So what by p would give you back p squared?
Piece of
PQ.
P. Right? Watch. If you're confused, the p is going to multiply by everything here. You have a p here and a p here. So that would turn to p squared. So 7p squared q. Wait, does that confuse you? Let me know if you understand that.
No.
All right. Next thing, Faith. What by 7 would give you back 14? Figure out what he's saying for now. What by 7 would give you back 14?
2.
Right, so I'm going to put 2 here. Now, you want to get negative 49, and you have positive 7 on the outside. So a positive by a what will give you a negative?
A positive by what would give you a negative?
So think of the
A
multiplication rules.
positive by a negative?
Yes. So I'll put -2 over here. Right? And that looks like it. Watch. Because if you multiply this out, right, the -2 or the -2 is going to multiply by the 7. What is 7 by -2? What is 7 by -2?
Negative 14.
14.
Right? And you already have the PQ over here, so -14 PQ. So this is correct. All right. Does anybody want to do a greatest common factor example with me again? Let me know, guys. Is there anybody that still feels iffy about this?
I feel iffy.
All right. Well, let's do some more questions. All right. So Perseus, suppose we have 10m cubed n plus 5m squared n. So Perseus, let me start off with 10 and 5. What could go into both 10 and 5? Say that again.
Also,
Say that again. You said 2?
yeah.
Nah, 2 can't go into.
Oh.
If you say 5 over 2, you're gonna get 2.5. I'm talking about. So when I say greatest common factor, I'm talking about the biggest number that 5 is divisible by and 10 is divisible by, without leaving a remainder. So if I can't use 2, because if I use 2, 5 over 2 is going to be 2.5 as a remainder. So what is the biggest number that could go into both 10 and 5?
I'll say
5, sir.
5. 5.
Per se, as 5. And if you're confused, watch. Could 5 go into both 10 and 5?
Yes, sir.
Yes, without leaving a remainder. So I'm going to pull out the 5. All right. Now, Perseus, if I have m cubed, what does that mean? What does m cubed mean?
Repeat, sir.
Yes. What does m cubed mean? M to the power 3. What does that mean?
Multiplying it. You multiplying 10 by itself, like
No,
3
not 10.
times.
Not 10.
I mean, m.
Yes, m. Because that power is the power for m, right? So m to the power 3. That would mean m by m by m. It means that you're multiplying m by itself 3 times. Understand?
Yes, sir.
And over here, how much times are you multiplying m by itself?
Twice.
So I have a question. In between both of the terms, right? What is the greatest amount of times you're seeing m? Like in both terms.
3.
Now, are you seeing 3m's over here?
No, sir.
Now,
I was looking at the next side.
so the greatest common factor. So what is the greatest number of m's you're seeing here and here?
5.
All right, so you see how we have 3m's over here?
Yes, sir.
And I have 2m's over there.
Yes, sir.
What would be in common is the fact that you're seeing 2m's. That's what they have in common. Both of them have 2m's. I feel like that confusing, yeah. So we have m by itself 3 times there, and we have m by itself 2 times there. What is the greatest amount of m's that you'll find over here and over here? It needs to be in common. If you tell me 3, right, that's wrong because are you seeing 3m's over here?
No, sir.
Now, so what's the biggest amount of m's you see in here and here?
2, sir.
2. So that means we could pull out m squared because m by m is m squared, right?
Yes, sir.
So we are going to pull out m squared. All right, so on to the next part. Are you seeing, if you notice, you're seeing n over here and you're seeing n over here. So that means we could actually pull out n. Now, if I pull out 5m squared n, the question is, what would I have to multiply by 5m squared n to get back 10m cubed n? So first things first, what by 5 is 10?
2.
2. And what by m squared will give me back the m cubed? So, Perseus, let Perseus do it. Because Perseus is the one having trouble with this. So, Perseus, m squared means m by m, right?
Yes, sir.
But you want to end up with 3m. So, m by m by m. You already have the 2m. So, what else you need?
1m.
Exactly. So, 2m, right? And well, you already have the n over here. So, it's just 2m. So, look at how this would work out if you multiplied it. So, Perseus, what's 5 by 2?
10.
And what is m squared by m?
3.
M cubed.
M cubed.
Because m squared means m by m, and you multiply that by m. So that's going to be m to the power 3. Because now you're multiplying m by itself 3 times. Right? And you have the n over here too. So you'll get back 10m cubed n. Right. Now, Perseus, if I pull out 5m squared n from this, right, what would I have to multiply by this to get back this? Do they look identical?
Yes, sir. 1.
Yeah, 1, right? So plus 1. Let's try to understand that Perseus. So again, Perseus, if I multiply this by 2m, 5 by 2 is 10, right? The m squared by the m, that'll turn to m cubed. And I have the n over here. So do you understand that we're getting back 10m cubed n?
Yes, sir.
Right? And if I multiply 5m squared n by 1, I'm going to get back 5m squared n. So that's how you factorize using the greatest common factor method. Let me know if you understand this.
Yes, sir. I feel like I just need a little more practice in it.
Yes. So let me show you another instance of greatest common factors, but this time with brackets. We're going to step things up a notch now. Okay. So suppose we had 2x, right, by x plus 3, right, plus 5 by x plus 3. Tell me, guys, are you all seeing anything in common between this term and this term? Anything at all?
X
Mm,
plus 3.
I'm seeing x plus 3 in common. If you look at it carefully, right, look at this carefully. You could see that there's x plus 3 over here, and there's x plus 3 over here, right? So guys, just by looking at this, what are you all seeing in common? What are you all seeing in common?
X plus 3.
Yes, x plus 3. Both of them, so both 2x and 5 are being multiplied by, if you check it
plus
out,
3.
right? 2x is being multiplied by x plus 3, right? And 5 is being multiplied by x plus 3. So both things are being multiplied by x plus 3. So if that's the case, I can actually pull out x plus 3 and tell my process, if I pull out x plus 3 from this, what will I write here? Take a guess, process.
Hmm.
So I
X
pull out x plus 3.
I
I
mean,
pull out x plus 3.
so what the minus told me,
All right, so if I pull out x plus 3, no, 2x. Okay, another way to think about it, right? If you divide by x plus 3, it's going to be 2x. Right, so this is going to be 2x over here. And for serious, if I pull out the x plus 3 over here, again, you can think of it as dividing. So what will I write over here?
5.
Plus 5. Right, so for serious, I see you need to do some work on algebra. So don't worry, get any practice, right? So for serious, yeah, let's say I have 6y, open bracket, e minus 2, right? Minus 3 by e minus 2. Tell me, Perseus, are you seeing anything in common between this and this?
A minus 2.
E minus 2, right? E minus 2. So if I have e minus 2 in common with most of them, I can actually pull that out. So take a guess. If I pull out e minus 2 from this term, what do you think I'll be left with on the inside?
6y
Right? And over here?
minus 3.
Yes. Does everybody in class understand that or not?
Yes, sir.
Yeah.
Okay. Let's step things up a notch. So what about, I mean, this is real straightforward, eh? This particular case, right? And you guys see anything in common there?
Yes.
Y plus 4.
Y plus 4, right? So I'm going to pull out y plus 4, right?
Mm-hmm.
If I pull out y plus 4, what am I going to write over here?
7x squared.
7x.
Right? 7x squared, right? Minus,
Minus 14x.
X.
but there's more factorization you could do there. Are you all seeing what I mean by there's more factorization that could be done or not?
Yeah. 7 and 14 could.
So what does 7x squared and 14x have in common?
7x.
7x. They have
Yeah.
7x in common. So if I were to factor out the 7x, what by 7x would give me back 7x squared?
X.
X.
Yes. Guys, check it out, right? What is x by x?
X
by
squared.
X squared.
Right. So if you multiply 7x by x, you'll get back the 7x squared. Right? What by 7x would give you back 14x? Figure out what is sign for now. What by 7x give you back 14x?
2.
2.
Right.
2x.
And we need to figure out whether it would be positive 2 or negative 2.
Negative.
Negative.
Because we want to get back negative 14x. So remember, a positive by a negative is a
A
positive.
positive by a negative.
A negative.
Right. So 7 by negative 2, that would give me back the minus 14, and I have the x over here. So I'll get back the minus 14x.
Wait, it wouldn't be negative 2x?
No, it wouldn't be negative 2x. Let me explain why. If I write negative 2x, right? 7 by minus 2 is minus 14, and x by x is?
X by x is x squared.
Right. Watch. See what I'm talking about?
No, but I'm referring to the x in front of negative 2.
No, watch. What is... Okay, so let me start back from scratch, right? So between 7x squared and minus 14x, both of them have 7x in common, right? Because
Yeah.
we're going to 7 and 7 could go into 14. Over here, you're seeing x squared, which means you have x by x. And over
Yeah.
here, you just have x. So if you look at the terms, both of them have 1x in common. So I pull out 7x, right? So what by 7x would give you back 7x squared?
What by 7x?
Would give you back 7x squared. So
Seven.
how would I get back x squared? So I have 7x already. Think. So remind me,
X.
what does x squared mean?
X by x.
Right. So if you already have 7x, you'll just have to multiply by x again so that x by x will give you back the...
Oh, wait, okay.
You
Okay.
understand?
Yeah.
Right? And over here, 7 by what would give you back negative 14x
Minus 2.
minus 2. I already have the x, right? So there's no need for me to put an x here already. I wonder if you understand this.
Yeah.
All right. Okay, good. So I'm doing a brief overview of all the different types you need to know, and then we'll do a bunch of past paper questions, right?
This is distribution.
No, if you want to expand it back out, you'll have to use distribution. But
Okay.
this is right now I'm factoring out the greatest common factor. So the next thing we're going to look at is difference of two squares. Do you all know about difference of two squares? Tell me, guys, do you all know about...
I can't really remember how to do
So
it,
forgetting
but
about
I
that.
know the topic.
Okay, so let me run through back difference of two squares, right? So anything that you have in the form a squared minus b squared, it could be factorized using this format. And I think you can see why we call it a difference of two squares. When you hear the word difference, what sign comes to mind? Difference.
Subtraction.
Right. And can we see you have a squared term over here and a squared term over here?
Yes.
So that's why we call it difference of two squares. Right? Anytime you have something in that form, you could say a plus b, right, multiplied by a minus b. And if you have trust issues, watch. Do you all remember how to multiply binomial expressions? Yes or no? Okay, you are a little quiet. So let me show you what I'm talking about, right? When I say the word binomial, does that confuse you? Does that scare you? Be honest with me. When I say the word binomial,
It
I heard the
means
phrase
two,
before,
right,
kind
sir?
of.
but binomial just means two terms. Can we see that you have a and b over here? So two terms.
Yeah,
Yeah.
sir.
And over here, you're seeing a and a minus b, so you have two terms again.
Yeah, sir.
So if you have trust issues, you could expand this back out. So to expand this out, you'd have to distribute the a across all the terms in the second bracket. So I'll multiply a by a, then I'll multiply a by, somebody tell me, a by. So a by a, and then a by,
B.
A by b.
not just b, negative b, right? And then I'm going to multiply b here by, take a guess. It's the same procedure. I'm
By
going to
a and then
By
b
A.
by b.
By negative B.
negative,
Yeah.
right? And let's see if we get back a squared minus b squared, shall we? So what is a by a?
A squared.
Right. For those of you guys that are confused, if I were to ask you what is 5 squared, what would you tell me?
5 by 5.
Yeah. So if I ask you what a squared is, what would you tell me?
A by A.
Exactly. So a by a is just a squared, right? Oh,
So you're
another.
sending this, you're sending this recording tonight because I want to write this down.
Yes, I'm sending this recording tonight. As soon as my laptop is finished processing the video, I will send it. And the recording today, it's currently being uploaded.
Okay.
All right. Yeah. Right. 1 second, right? Are you drinking coffee tonight? Let me know. What are you doing tonight? What are you doing tonight to keep all up? Like, to keep yourself
I
up?
don't like coffee, so I just gonna wing it and pray that
Uh,
I stay up.
yada yada. The vibes, boy, the vibes. I find like everybody real quiet. I don't know. And
I'm so tired.
for some reason, I feel real tired. I don't know why. I feel like the, I feel like it's finally getting to me. But the badness of, but the show must go on, right? So let me go. So
It's
I,
the rain and it's nighttime.
it rained.
By me raining.
The whole day it's raining.
Wash it, nothing.
So
Anyways, what is A by A? A by A,
A squared.
right? What is E? So we did A by A, right? What is positive A by negative B? First of all, what's a positive by a negative?
A negative.
Right, so I'm going to put negative here one time. And what is A by B? Well,
A B.
that's just AB, right? Don't let you confuse you. Then we have positive B by positive A. That'll just be positive what?
Positive. A B.
Yeah. If you're confused, check this, right? So A by A is A squared. Cool. That literally is A by A, right? A squared. Then we have A by minus B. So forget about the sign for now. A by B is just AB. But this is a positive by a negative. What's a positive by a negative?
A negative.
Right? So hence negative AB. Then we have positive B by positive A, which is just plus AB. Did I confuse you or like really badly or like let me know what's going on?
No.
Okay. Then we have forget what it signs, right? What is B by B? B by B.
B squared.
Right. But as you guys would have noticed, we have a positive B here and a negative B. What is a positive by a negative?
Negative.
Right. So guys, if you have okay, so can all of us agree that negative AB is the opposite of positive AB?
Yeah.
So what happened then? If I ask you what is negative 5 plus 5, what will you tell me? Okay,
what is
that confusing some people. Imagine you have imagine you had
Got nothing, sir?
exactly. Imagine you was owing somebody $5, right? Okay, so okay, let me just say he was owing the bank $5, right? If he was owing the bank $5, what would show in your balance?
Negative 5.
Right. And let me just say you put $5 into your bank. What's your new balance?
Or 0.
Zero, right? Right, zero. It's the same concept over here. Negative AB come like negative 5. And if you add AB to it, come like positive 5, it's constant to zero. So anytime you are combining the opposites, they cancel off. So negative AB plus AB is, somebody tell me, zero. Yes. That whole thing is just going to be zero. So we are going to end up with A squared, what? A squared?
minus B squared?
Right. So guys, this is why we could write anything in this form as a product of these two factors, A plus B, A minus B. I wonder if you're confused by the distribution. I know it looking a little scary. You're seeing a bunch of letters, you're seeing signs.
So for like these two squares, right?
Oh.
So in the brackets, it will be like the same kind of numbers, but one bracket will be plus and the next bracket will be negative,
Yeah,
Yeah.
basically.
yes. But this part over here was just to show you some how to distribute things, right? Okay, so let's look at an actual example now. So I'm gonna start you guys off very like babyish, like real simple. Imagine you had x squared minus y squared. If you notice, the x takes the place of what over here?
A squared,
It come like it taking the place of a, yeah? And the y come like it taking the place of the b. So apply that same logic over here for me now.
it will be x plus y and then x minus y.
Yes. Is there anybody that can't understand that at all? Tell me. If you can't, I will go it over to my best of my abilities. Let me know what we know. You understand? Let me know.
Yes, sir.
Yes, I understand this
So
part.
could you just go back and explain a bit? My internet had cut out for a bit, so I didn't see. Yeah, explain it.
All right. So anytime you have something in the form a squared minus b squared, you can factorize it as a plus b by a minus b. So essentially, whatever is being squared here and whatever is being squared here, you add them here and you subtract them over here. Understand?
Yeah.
So look at this, right? And Aaron, as you.
Yes, that's me.
All right. So can we both agree that x squared minus y squared is in the same format as this? Like both of them are in the same format. Yes or no?
Yeah,
So the x here come like it takes the place of the a, doesn't it?
yeah.
And the y here comes as though it's taking the place of what?
The b squared.
Right. So what I'm going to do is I'm going to write x plus y, right? And then x minus y. Let me know if you understand that.
Yes, I get it.
So let's look at I'm gonna make things a little more complicated. What if you had 16 minus 9? Now, guys, with these types of questions, you need to write everything as a perfect square first. Can somebody tell me what 16 is as a perfect square? 16 is the same as what? What squared?
4 squared, sir?
Right? 16 is the same thing as 4 squared. Do you all understand or not? Tell me.
Yes, sir.
I get it, sir.
All right. And 9 could be written as what squared?
3 squared.
And if you are having a hard time figuring this out, you could use the square root function. Watch. Square root of 9. 3.
It's tree. Yeah.
Right? Okay, guys. So tell me, is this in the same form as this?
Yes.
Yeah, sir.
What is A and what is B? Over here.
4 is A and 3 is
4.
B.
Right. So I could write that as 4 plus 3, right? By what?
4 minus 3.
Now, this was a simple example. It will never come this easy. It will never just be numbers. It was just so they could see what's the general process. Right? Right. So Aaron, I'm gonna make things a little more complicated, right? So let's
Okay.
say you had x squared minus 16, right? X squared minus 16. Tell me, is this in the exact form as this? Are both of them being squared? Yes or no?
Well, the x is squared, but the 16 is unsquared.
But is that hard for me to write 16 as a perfect square?
No, it'll be x squared minus 4 squared.
Right. And I could write that as, you tell me.
X plus 4 and X minus 4.
Yeah, guys, is there anybody that doesn't understand this at all? Tell me.
I understand.
You understand it?
Mm-hmm.
Yeah.
Okay, nice. Okay, so I'm gonna do a slightly harder example. Say for instance, you had 9y squared minus 25. How much of you all attempted to say 9y squared minus 5 squared, and the answer would be 9y plus 5, 9y minus 5? How much of you guys attempted to say that?
I
Now,
probably
so if you do that, it
would
will
have
be
said that
81.
if in the exam, so
Exactly. Somebody mentioned the loophole. You get 81, right? So there's definitely something wrong with that. But this is the mistake students make every single time. What you need to do is you need to write all the terms as a power of 2. So right now, 9 is not being raised to the power 2. So you'll need to ask yourself, okay, is there any way I could write 9 as a perfect square?
3 squared, so
Right, so you're going to write 3 squared by y squared, right? And 25. 25 is what squared? Tell me, guys, 25 is what squared?
5 by
5 squared.
5 by 5. Yeah.
Exactly. Now, guys, can we all see that both of these terms are now being squared?
Yeah, so
Yeah.
So how I can write that is actually as 3y all squared. The brackets are very important. If I leave out the brackets, I'm just telling them that I'm raising y to the power 2. Oh, you understand what I'm saying, right? If you don't have brackets, this means y is the only thing being raised to the power 2.
yeah,
Yeah.
But if you have the brackets, it's telling the reader that both of these are being raised to the power 2, which is what is
the
happening.
entire thing is being squared.
Exactly. So, okay, guys, is this in a perfect square form now? I mean, difference are two
Mhm.
squares form? Yeah. So what is A
Yes,
and what
sir.
is B? What is A and what is B?
3 would be 8.
3y would be A and B would be 5. So what would I write here? You all tell me.
3y
Mm-hmm.
plus 5 squared.
Nah.
No, just 5, sorry.
3y plus 5 by...
5.
3y minus
3y
5.
minus
5.
5.
Okay, and who here has trust issues?
Me.
So let me show you how we could check if your answer is correct, right? All you have to do is expand the brackets and you are supposed to get back where you started with.
Yeah.
If you want to expand this, you're going to take the 3y and you're going to distribute it across all the terms in the second bracket. And you're going to repeat that same process but with 5. So you see this 5 over here, you're going to multiply everything in the second bracket by 5. And we're supposed to get what if we are correct? Like when we finish, simplify. If we are correct, what are we supposed to get back?
3y to
9y
the power
squared
2.
minus
I mean,
25.
not, sorry.
Yeah, supposed to
Yeah.
get 9y squared minus 25, right? So guys, first of all, what is 3y by 3y?
9y
9y squared.
squared.
Okay, what is 3y by minus 5? Now, first things first, guys, what is 3 by 5?
15.
15
Is that positive by negative?
or negative.
Negative.
Right, so it's going to be negative 15y. Let me run that back one more time.
Oh,
So you're multiplying 3y by minus 5. So 3y by minus 5, right? So 3 by y by minus 5. So I could rearrange that. I could say 3 by minus 5 multiplied by y. What is 3 by 5?
15.
15
Is that positive or negative?
A
negative.
negative.
Negative 15y. Are you all confused?
No, sir.
So again, watch. 3 by negative 5, right, as negative 15. So negative 15y. Is anybody extremely confused on how I got negative 15y?
So
No,
we don't
sir.
get to know the answer.
So I
Or
get
not
no.
the answer.
We have finished yet, you know? We have finished yet.
Oh, oh,
Over here. And we still have to multiply everything out by 5.
Yeah.
Yeah,
Right. So what is positive 5 by 3y?
15y, so
15y.
Right.
positive 15.
Because 5 by 3 is 15, right? So 15y. And right, what is 5 by minus 5?
Negative 25.
If you are confused, figure out what is sign for now. But tell me, what is 5 by 5?
25.
And what is a positive by a negative?
A negative.
Right, so negative 25. Is there anybody that's majorly confused?
No, sir.
No, so I understand.
And let's verify this thing now. Guys, imagine if you had minus 15 in your bank account, right?
Hmm.
Right? And you and you add 15 to your bank account. And what's your balance?
0.
0. So if you have negative 15y and you add 15y, what would all of this simplify to?
0.
0. 0, right? Once once terms are opposites of each other, they cancel off. I can all of us see that this is negative 15 and this is plus 15?
Yes.
Isn't that the opposites of each other?
Yeah.
So if they're the opposite, they'll cancel off, right? And if they cancel off, I'll only be left with 9y squared minus 25. Is that what we started with?
Yeah, sir.
Yes or no? Is that what we started with? 9y squared minus 25.
Yeah, sir.
Yes, sir.
Right, so we are correct, right? And this is optional. This is proof. All right. So guys, who wants to do a question one more now? Who wants to do a difference of two squares question one more?
I could try.
All right. So let's go. So what if I have 100 p squared, right? Minus 36 q squared. Now it looks complicated, but I want you to ask yourself, could I write these numbers as perfect squares? And to answer that question, just find a square root. Which is square root of 100?
By 10.
10, right? And where's 10 by 10?
That was a 10.
Right, nice, 10, right? So 100 is the same thing as 10 squared, right? So
And
10 squared,
36 would
yeah, 36 is?
36 would be 3.
Nah,
No,
3,
12, sorry. 12, 12.
nah. 12 by 12 is 144. Let me ask that question, right? What is the opposite of square and something? We did it a lot when he was doing trigonometry. What's the
I
opposite
know
of
what you're talking about.
square what?
It's
Square root,
square. This,
right. So if you having a hard time trying to figure out what number by itself is 36, you can find the square root of 36. Yeah, that what I mean. We go find, yeah, square root of 36 and I calculate,
6.
right? So if you're having a hard time, just find the square root of the number.
6.
So 6, right? So I could write 36 or 6 squared. That confusing you, understand that,
No, understand.
right? And I'll write back q squared. Now, can you see that we're squaring both of these terms?
Yes.
So I could write that as open bracket. You need to put the brackets there. You need to. You need to.
We,
You need to. You need to. All right.
you can put the brackets one time.
Wait there. You need to show this working. You need to show that 10 squared p squared is the same thing as 10p squared. Because you need to put it in a differential squares form first before you could factorize.
Yeah.
And what do you think I'm going to write here?
6q squared.
Exactly. Tell me, is it in a differential squares form now?
So I don't mean to be like rude or anything, right? But like I could drop a recommendation real quick.
Sure, no problem.
So like like how like some students would like take a while to like understand the topic while they're teaching it, and like some of them would like understand already.
Mm-hmm.
It would be cool if you could like before you start like a topic to like have a like a small worksheet or something ready. So like like the ones that understand can like take a screenshot and like start working on it. And like while they're going through the others, the ones that understand could just work through, and when they finish it, everybody would be correcting it along with you.
Okay, sure, no problem. All right, I have a worksheet. Check it finance. Let's see.
Yeah, boy, the vibes were out there and I'm seeing missing. Everybody tired.
Yeah, boy. Sheets. Here what we do, right? I'll send a functions worksheet. This tests your knowledge on everything. Algebra, functions, graphs, everything. Right? So Darius, if you want to like stress your brain out and make sure and see if you understand everything, you can try this worksheet. Right? So I'll send it to you.
So
Right? All right. Yeah, so let me go back into it, right?
Mm-hmm.
So this is in the difference of squares form now, right?
Yeah.
So how could I factorize this? Tell me, how could I factorize that?
You do 10
10p,
p,
mm-hmm,
yeah, plus 6
right?
q
Right?
and 10p minus 6q.
Right. And if you were to expand that, you'll get back the original thing. Let me know if you understand that. So do you know how to do factorization by difference of two squares now?
Mm-hmm.
Okay, nice. So is there anybody that doesn't understand difference of squares or nah? I mean, if you understand. Is there anybody that's still really
I understand.
so to do this, you first need to write everything as a squared term. So 10, so like 100 p squared. 100 is the same thing as 10 squared, right? So 10 squared p squared, all of that is 10p squared. So you need to write everything as a squared term before you could start to factorize, right?
When you finish, teach us all of the types of algebra. You could tell us how to identify which one to like, which method to use.
Sure, not a problem.
Okay.
Right. So now we're going to move on to quadratics. Do you all know how to factorize quadratics? Or let's give all the trouble.
Yeah, things give me trouble, so
Right,
Sometimes you get trouble sometimes.
let me look at how to factorize quadratics, right? We're going to look at two cases. The first case we want to look at is when the coefficient, right, for a is equal to 1. And I have a really good hack for this. So, right, 1 second. So let's start off with example 1. So x squared, right? So x squared plus 5x plus 6. So let me show you how we're going to do this, right? I want you to open up two big brackets. First things first, what would you have to multiply to get back x squared? Tell me, guys,
x by x, so
x by x, right? And then I want you to look at the last two. What is the last two?
6.
6. I want you to think to yourself, how could you multiply? So how could you multiply to get 6 and add to get plus 5? Right?
3
So,
and 2, so
right. So what two numbers would add to give right? Yeah, what two numbers would add to give 5 and multiply to give 6? So 2 and 3. Guys, if you multiply 2 and 3, what are you going to get?
5.
6.
I said multiplier. So 2 by 3, 6.
Oh, 6.
And if you add them, what will you get?
5.
5.
Right? So watch. They multiply to give 6 and they add to give 5. So that's how I know that's the correct numbers to use. So I'm going to put plus 2 here and plus 3 over here. If you wrote plus 3 over here and plus 2 over here, that would have been fine. All right, let me know if you guys okay with this so far. Let me know.
Yes, I understand it.
And how could you check to see if your answer is correct? Tell me.
By multiplying
Yes, you need to,
numbers, and then the two numbers had to add up to the number in the middle.
right, you need to expand this. So you'd say x by x, right? And x by 3. Then you would say 2 by x, right? And then 2 by 3. So what is x by x?
X squared.
Right? And what is x by 3?
3x.
Right? What is 2 by x?
2x.
Right? What is 2 by 3?
6.
Right? So as you can see, we have like terms here. What is 3x's plus 2x's?
5x.
Did we get back the original expression we started with?
Yeah.
Yes. So we are correct. Let's look at a different example. So this is like a shortcut version of the AC method. When the coefficient of x squared is not 1, then we'll use the AC method in its full extent. And then we'll do the full version of AC method. But this is the easiest way to factorize most quadratics in CSEC maths. Right? Okay, next one. Let's just say we had a squared, right, plus 9a plus 20. So now, I'm gonna know if you're there.
Yes, sir.
All right, so then now, first things first, right? The first term here is a squared. How would I multiply to get back a squared? What by what is a squared?
A by itself.
So a by a, right? So I'm gonna put a over there, and I'm gonna put an e over here, right?
Yes, sir.
Next thing, I want you to look at the last term over here. What is the last term over there?
20.
20, right? Okay. Here I'm gonna ask you, right? How could you multiply to get 20, but add to give me the middle term? So how could you multiply to get 20? What two numbers you could multiply to get 20, but those two numbers need to add to give you 9. So give me some suggestions. What two numbers would give you 20 when you multiply them?
5.
5 and?
2.
Nah, 5 by 2 is 10 and 20.
5.
Nah, 5 by 5 is 25. So 4. 5 by 4 is 20.
Okay.
And if you have enough, right? And if you have enough,
Okay, let's see.
I find it maybe a little bit more sense for me. Yeah.
I is about 2 numbers.
Oh yeah, I see what you mean. See what you mean. Yeah. So I hear what's it once here, right? I don't know. You told me 5, right? If you had 5 on 5, you get back 9? Tell me.
No.
Yeah. If you had 5 on 4, though, will you get back 9?
Yeah.
And where's 5 by 4?
20.
9.
20, right? So 5 plus 4 is 9, right? And 5 by 4 is 20. So my
Yeah.
answer is going to be A plus 5 and A plus 4. Let me know if you understand this.
Yes, sir.
All right, so now we do our next question together. So what if we had m squared, right, minus 4m? So I'll throw in signs into this now. This is where things get a little tough. Right, so then now,
Yes,
tell me, what is my, so I've already put the m by the m, right? M squared. What is my
Yeah.
last term?
What is it?
What is my last term over here? My last term,
21.
21, right? Not just any 21, but negative 21.
Okay.
Negative 21. So how could you multiply to get negative 21? Let me hear some suggestions. And forget what the negative sign for now, right? But remember something, right? When you combine them, it's supposed to give negative 4. So just give me some suggestions, right? How could you multiply to get 21?
7 trees.
Okay, stay with me. So 7 and 3, right?
Yeah.
Now, we want to get back negative 21. So to get back a negative term, and try to multiply a positive by a negative or a negative by a positive,
Yes, sir.
right? So my question is, if you want to get negative 21, you had to put a negative by one of them. Now, pay attention to the term in the middle. The term in the middle is positive or negative?
A negative.
It's a negative, right?
Yes, sir.
Where do you think I should put the negative number? By the 7 or the 3?
By 7.
Exactly, because if I put the negative number by the bigger number, wouldn't that make my end result negative?
Yes, sir.
Yeah, right? So let's run through it again. What's negative 7 by 3? Negative 7 by 3 is,
21. Negative 21.
right? Negative 21. And what is negative 7 plus 3?
Negative 7 plus 3 is negative 4.
Does it check out?
Yes, sir.
Right? So my answers are negative 7 and plus 3. And again, if you put plus 3 over here and you put in negative 7 over there, it's fine, right? It's fine.
Okay.
But you can only do that if the coefficient for the squared term is 1. So, you see always just x squared over here? You're not seeing
Yes,
it.
sir.
That means 1x squared. You're not seeing it
Okay.
over here, but it's 1a squared. You're not seeing it
Okay.
over here, but it's 1m squared, right?
Yes, sir.
When we look at examples where the coefficient is not 1, you'll see what's going to happen. But let's do one more to make sure like it's locked in. And if any of you guys are confused by this, just let me know, right? Stop me and let me know. What if we had p squared plus p minus 12? First things first, I'm going to open up two big brackets, right? Put p over there, put p over there, right? And what is the last term there? What is the last term over there?
12. 12.
Positive 12 or negative 12?
Negative 12.
Negative 12, right? So tell me, how could I multiply to get negative 12?
Um,
So again, forget about
okay.
the sign for now. We just want to see all the possibilities. So it was almost 6 by 2.
Yes, sir.
Let me see if that will work, right? So we want to get negative 12. And what are you seeing in the middle?
Positive. Positive p and negative 12.
So positive p means plus 1p. You're not seeing it, but it means plus 1. Because how much p is you seeing over here?
1.
1p, right? So whatever answer you pick, when you work it out, right, it's supposed to give you plus 1. Now,
Okay.
check this, right? Negative 12. And to get a negative number, you have to multiply a positive by a negative, or a negative by a positive.
Yes, sir.
So if I put the negative by the 6, it's negative 6 plus 2. Will that be 1?
No.
Nah. Okay. What if I put the negative by the 2? That would be 6 minus 2. Would that be 1?
No.
Nah, so we need to think of some other factors, right? What are some other ways we can multiply to get 12?
So 4 by -3.
Yeah, that sounds correct. So now watch. If you multiply 4 by 3, aren't you going to get 12?
Yes, sir.
Right? And you want to get positive 1. So I should put a negative number by the smaller one. That makes sense?
Yes, sir.
Because where's 4 minus 3?
1.
Exactly. Right? I trust I understand this. So
Yes, sir.
plus 4 over here and minus 3. Right, so that's how you would deal with quadratics whose coefficient for the squared term is 1. Let me know if you'll understand this. Is there anybody that's still well lost? Tell me.
Nah, sir.
No, sir.
All right, so let's look at a trickier example. What happens when you have a quadratic, right? Where a is not equal to 1. Let's see what's going to happen. Right, so Aaron, let me do the first question together, right? So let's just say I have 2x squared plus 7x plus 3. So guys, can we see that in this example, the number in front of x squared isn't 1? Come before let's see it now.
Yes, sir.
In all the prior examples, was there anything in front of the square term?
No, sir.
No, so that would have meant 1, right? That would have meant it was 1, so 1x squared. But over here now, you're seeing a number other than 1. Right. So Aaron, are you familiar with the AC method?
No, sir.
All right. Can we both agree that this is in the form of a quadratic, right?
Yeah, it's in a quadratic form.
Right, so ax squared plus bx, right, plus c. Tell me, what is a, b, and c? What is a? If you compare any coefficients, what is a? Like, you would be.
What you said, sir?
So we both agree that it's in a quadratic form, right?
Yeah.
So if you compare this and this, what do you think a is?
2.
Yeah,
Oh.
a would be 2. Aaron, check it out. A is 2. Aaron, really miss
Yeah.
out. What do
I
you think
see,
B,
sir.
what do you think B would be?
7,
And C?
3.
Right. So how this is work, right? We're going to multiply A by C, right? What is A by C?
6.
6, right? And here, what way to do for now? I want
Mm-hmm.
you to ask yourself, how can I multiply to get 6, right? But add to give me the term in the middle. So what two numbers would multiply to give you 6, but add to give you 7?
1 by 6, sir.
I'm not going to say it, guys. I'm not going to say it. So you said 1 by 6 cents?
Yeah.
So, and if you add 1 and 6, what do you get back?
7.
So here what we're going to do, right? We are going to rewrite the middle term as a sum of these numbers. So I could write 7x as what plus what?
1 plus 6x. Oh, okay.
Yeah. Tell me, guys, did this confuse you? Like, do you all know that 7x is the same thing as 1x plus 6x or not?
Now I see it, sir.
Guys, do you all know that 1x plus 6x is the same thing as 7x or not?
Yeah.
Oh, you know that?
Yeah.
Yeah, okay. I don't hear much people, so that's why I keep asking. I need like some feedback, right? So here what we're gonna do, right? Aaron, we essentially are going to do greatest common factor with brackets. That's what
Oh.
we're gonna do. So let me ask you a question, right? And this might look a little complicated. I'm going to look at half, you see this expression over here? We're gonna split it into halves, right? Think of it like that. So is there anything in common between 2x squared and 1x?
The x,
Right? The x. If I pull out x from 2x squared, what would I write?
Just 2x. No, not x squared.
Right?
Just singular x.
Because why? Because if you multiply 2x by x, the x by x is going to give you
1x.
new. Nah. What is x by x?
Oh, sorry. X squared, x squared.
Right. And what by x would give you back 1x?
One.
Yeah, 1. Right, so Aaron, 1 by x is 1x. Watch. 1 by x is 1x. Tell me if you understand that, Aaron. Aaron? Okay. I'm not hearing from Aaron. All right, so guys, tell me, if I have 6, I'm now going to move on to the other half, right? Are you all seeing anything in common between 6x and 3?
3.
So we're going to factor out the 3. So I'm factoring out positive 3, right? Positive 3. So if I pull out 3 from 6x, what would I need to multiply by 3 to give me back 6x?
2.
2x.
2x. And if I factor out 3 from 3, what by 3 will give me back 3?
1.
1.
So a little hint here. If you're doing it correctly, we get in this bracket is going to be the same thing in this bracket. So now we could just pull out the greatest common factor that's present in both terms. So are you all seeing anything in common between here and here?
2x plus 1, sir.
Right, 2x
And
plus
then x plus 3.
exactly x plus 3. And that's it. So, Aaron, if I pull out the 2x plus 1 from here, I'll put the x there. If I pull out the 2x plus 1 from over here, write the 3 over here. Let me know if you
Yeah,
understand.
I see it, sir. I get it now.
All right, nice. Now, when I'm personally doing quadratics, I never do it like this. But I realized over the years that this is the most safest method for students, right? Like I would look at this and see the answer just because of how much time I did quadratics. But at this level, I think, this is the safest method to use.
So,
So,
so the final answer is 2x plus 1 times x plus 3.
yes, that is it.
Okay, so the part here with 1x plus 6x, that's not fine. I thought that was the final answer initially.
Now, you ever wonder why we call it factorize?
You have to break it down to its lowest point.
Yeah, you have to break it down into a product of its factors.
Oh,
You do have maths by chance?
no, sir, I never did.
You sound like you go like hard maths. Believe it or not, right? Did you know that these things could actually go into this without even knowing me now? Yeah, that is,
Yeah, I can see it. Yeah.
but that is why we call it a factor, right? And the factor and that factor could go into another number without even a remainder.
Yeah.
Yeah. So we call it factorize because we are listing the expression as a product of its factors. That's why. And if you had trust issues, you could have expanded this back out, and you're supposed to get back 2x squared plus 7x plus 3. So
I was just asking, sir, because I think when my teacher was teaching us in school, they said that this part here with like 1x plus 6x, they said that was the final answer, so we didn't do all this here.
that's crazy. Come on. This man saying his teacher in school said that this was the final answer. The factorize a quadratic. 2x squared plus 1x plus 6x plus 3. That's crazy. Supposed to be something. And illegal.
So I have a question, right? And take a work out
Say that again?
these questions like using the quadratic formula as well.
Yeah, but
But like
that's real score for this.
oh okay, but like if you was to get the answer, like how would those answers relate to these two?
All right, watch this, right? So you're probably wondering how would you find the x, right?
Right?
That's what I think you're asking me, because if you use the quadratic formula, you can find the x. So if you want
Oh,
to
okay.
find for x over here, you'll put this equal to 0. And you'll put each linear factor equal to 0. So you'll say 2x plus 1 is equal to 0. and you'll say x plus 3 is equal to 0.
Oh,
From
and you just
this
like
side.
okay.
So those will be your answers.
Oh, okay.
Yeah. Right, remember, when you solve a quadratic equation, that's when the y value of the function is equal to 0. That's when the whole function is equal to 0, because the roots are the x-intercepts of our graph. That's where the graph cuts on the x-axis. So you'll put the entire thing equal to 0 and solve.
Okay, sir.
All right. So let's move on to another question, just to make sure and see if you understand it. So who wants to do another question right now? Don't be scared. If you'd be scared, you wouldn't learn. So who wants to do our next question?
I'll give it a try, sir.
Okay, Perseus, I like the spirit. I like the spirit. So Perseus, first things first. Try to figure out ways A, B, and C from,
5 is
right?
A, and for B is 13, and C is 8.
Right, so the first thing I want you to do is multiply A by C. What is 5 by 8?
5 by 8 is 40.
Right? How could you multiply, right? To get 40, right? But also add to get 13. Right? So tell me, Perseus, what are some ways that you know you could multiply by like, okay, what are some numbers you know you can multiply to get back 40?
I know 10 and 4.
Right, but if I use 10 and 4, right? If I use 10 and 4, what's 10 plus 4?
10 plus 4 is 14.
Would I get back the middle term?
No, sir.
Nah. Think of some other ways you could multiply to get back 40.
I was going on say 2 and 20, but no.
Because if you add 2 and 20, you get 22. That cannot.
Yeah, I would.
I'll give you a
Oh,
hint.
that sounds
5 by what? 5 by what?
5 by 8.
Yes. If you add 5 and 8, you get.
It was right in the question. Yeah,
If you add 5 and 8, what will you get?
13.
Exactly. So 5 plus 8 is equal to 13. But here what? We are going to split our p term in 2. Right? So you see that 13 over here? We are actually going to split it up, right? So I'll write 5p squared plus
5p squared plus 5 plus 8.
5p,
I mean 5p plus 8p plus 8.
right? Now here we're going to do, right? I want you to split this in half, right? To split that in half, and I want you to split this in half, right?
So it will be p open bracket.
Now,
No.
you're seeing anything in common? Like, okay, other than, like, yeah, you're seeing p in common, right? But what else you seeing in common?
The 8, the 8p and the 8.
Wait, we're looking at this. So like
Oh,
you look at the
5
expression in halves, right? So tell me, what do we have in common between 5p squared and 5p?
p,
Not just the p's. I'm seeing something else in common.
the 5.
Yes. So I'll pull out the 5, and you're saying you're also seeing p's, right?
Yes, sir.
So how much p's will be seen over here? It's p squared, so that means 2, right?
1,
And
4, 1.
I have 1 here, right? So altogether, you have 1p in common in both of them. So I'm going to pull out 1p. So if I pull out the p, tell me, what by 5p will give me back 5p squared?
P, sir.
P, yeah, watch. What is 5p by p?
5p squared.
Exactly. So p here, right? And what by 5p will give you back 5p? It's not a trick question. So I'm gonna ask you this, right? What is 8 by 1?
8 by 1 is 8.
What is any number by 1?
Any number? 1?
Yeah, like if I ask you, what is 76 by 1?
76.
So if you want to get back 5p, right, and you have 5p, how would you multiply 5p by?
1.
Exactly. So plus 1, right? Understand that?
Yes, sir.
Okay. Now we're going to move on to the green part. So are you seeing anything in common between 8p and 8?
Only seeing 8.
Right. So you're going to factor out the plus 8. What by 8 will give you back 8p?
1?
Now, 1 by 8 is 8. We'll think about 8p.
Oh, 1p?
Yeah, 1p. So just p, right? Remember, I tell you, if you do it correctly, whatever you get in this bracket, you're supposed to get in this bracket. So you cannot figure out what you're going to get in this bracket inside. Plus 1. And maybe you doubt him, no? Watch. What is 8?
No, sir. No, sir. I actually doubted myself. That's why.
Nah, it's fine. Well, it's not fine to doubt yourself, right? But you'll get over that soon enough. What is
Just
8 by 1?
overthinking.
What is 8 by 1?
Is 8.
Right. So can you see that we have p plus 1 here and p plus 1 over here?
Yes, sir.
So we're actually going to factor out the p plus 1. If I factor out the p plus 1, what am I going to write in these brackets?
Will it be 5p plus 8?
Exactly. So do you understand this method?
Yes, sir. I mean, 2 more questions. I think I'll do good.
Say that again.
I think if I do like 2 or 3 more questions, I'll get it completely.
I think so. So who here wants to do one of these questions right now? I think now is the perfect time. If you want to learn, for you to come and try to do it. I think it's the perfect time now. Austin, you there? Austin, I'm gonna know if you're there.
Yes, sir.
All right, so Austin, let me try our thing, right? Let me try our thing. Have you ever done the AC method in school before?
Yeah, but it's forgotten plenty.
All right, well, let me give it a go. Let me try something. So 4a squared, right? Let me just change that to x. So 4x squared, right? So let me just say we have 4x squared, right? Plus 12x plus 9. All right, so here on. First things first, you think you can tell me what A, B, and C is?
A is 4, B is 12, and C is 9.
Oh, Austin to answer this, right? Austin, that confuse you?
Nah,
Nah? All right, so Austin, next thing I want you to do, right? I want you to multiply A by C. What is A by C?
36.
Right, so my question for you is, how could I multiply to get 36, but add to get 12? Think of a way you can do that. So what by what is 36?
Six and 6.
Yeah, excellent. 6 on 6, right? Right, because when you add 6 on 6, what do you get?
36.
Now, when you add it, 6 plus 6 is?
Oh, we get 12, we get 12.
Right, so we good. So Aaron, what's saying? Austin, yeah, what's saying, right? Aaron. Yeah, Austin, you know what we're going to do with that 12x? We're going to split it into 6x and 6x. So I'm going to write 4x squared, and instead of writing 12x, what am I going to write?
6x plus 6x.
Exactly, 6x plus 6x plus 9. Awesome. So let me ask that question, right? Okay. We want to split this up into two different parts, right? Now, I want to ask you, what is the greatest common factor between 4x squared and 6x? Are you seeing anything in common between 6?
Is it?
Are you seeing anything in common between 4 and 6?
12?
12? Nah. Let me explain, right? Could 12 go into 4? Nah. A bigger number can't go into a smaller number. So think of a number that could go into both 4 and 6 completely.
2.
2. How much times 2 could go into 4?
2 times.
And how much times 2 could go into 6?
3 times.
Okay, good. So we're going to pull out 2 there, right? And not just 2. Let me ask that question. Over here we have x squared, right? That means you're multiplying x by itself how much times?
2 times.
Right? So over here you have x by x. And over here you just have x. So how much x you have in common between both of them?
3.
Nah. How much x is you seeing here? 2, right? And over here?
Wait. 1.
So how much, like, you can't say the answer is 2, right? Because this one don't have 2, right? This you only have 1 here. So the amount of x's you have in common in both of them is 1. Because then you have 2 x's here, right? And you
Yeah.
have 1x over here. But entering both of them, at least you have 1x.
Yeah.
Yeah. I cannot say that both of them have 2 x's in common. Because does this have 2x?
Nah, that's 1.
Just 1x. But so can we see that in both of the cases, yeah, both of them have 1x. Can we see that?
Yeah.
So we're gonna pull out 1x. So we're gonna pull out 2x altogether. Someone that confused you.
Nah, then
All right. So what by 2x would give me back 4x squared?
2. 2.
Right? 2. And what by x would give me back the x squared?
X.
Correct. Now we're gonna look at the 6x. What by 2x would give me back 6x?
3.
Yeah, plus 3, right? You
Yeah.
following with me so far?
Yeah. Yeah.
All right, nice. Then okay, next stop over here now. Are you seeing anything in common between 6 and 9?
3.
3. So if I pull out the 3, I pull out positive 3, right?
Yeah.
What by 3 is going to give me back 6x,
2x.
right? And what by 3 is going to give me back 9?
3.
Are we happy? Tell me, are we happy? Are we seeing?
Yeah.
Yeah, yeah, we're chilling now. So tell me, are you seeing anything in common between this and this?
It will be 2x plus 3 and 2x plus 3.
Yep. Right. So Austin, what do you think about it? Hard or like you think you could manage it?
Nah, that's easy.
Good. Happy to hear that, right? Happy to hear that. Um, before we move on, guys, does anybody else want to do one more question like this with me? The floor is open. Tell me, guys. I'm willing to do.
Yes.
Perseus, you again? Let me do another one.
Yes. Mhm.
Okay. I like how you're moving today, Perseus. I like how you're moving today. I like this. This is good.
I mean, so I want to make you proud and myself too.
Exactly. You don't want me to be like this, right? You don't want me to be like like this. I might jump, you know?
No, sir, no, sir.
right? So, I'm just the first question I didn't give you before. All right, so process, let's go, right? So 3x squared, right, minus 11y plus 6. So process, see if you could, wait, x. Yeah, so process, see if you could tell me what A, B, and C is.
A is 3, B is 11, and C
Make a mistake
is
there. B is minus 11.
negative 11. Yeah. And C is 6.
Right. So you need to find A by C. What is A by C?
A by C, that is 18.
So I need you to think to yourself, right? What by what could give you 18, but also combine to give you negative 11? This one is a bit tricky.
Yes, it is.
So process,
2 by 9.
is it 2 by 9? 2 by 9?
Yes.
Okay,
Yes.
I like where you're going with this, right? Now, is 2 by 9, is positive 2 by positive 9 the only way to get positive 18? Remind me, how are some ways I can multiply to get a positive? So a positive by a positive is a positive, sure. Or what else is a positive?
A negative by a negative.
Right, so what am I going to do? I'm going to put a negative here and a negative here. Because what happens when I combine negative 2 and negative 9?
You'll get a positive.
Yeah. Yeah.
Oh.
If I multiply them, I get a positive, sure. But if we combine
You'll
them,
get negative.
right? If I add them, watch. If I add them, right? So if I say negative 2 plus negative 9, what do I get?
You'll get negative 11.
Yeah. Right?
That
So,
was my bad, but I misheard. I thought it said multiply.
oh, no, no. Right? So we're going to go use this, right? So instead of writing minus 11x, what am I going to write?
3x squared minus 2x minus 9x plus 6.
All right, so this one might be a little hard for you, but I like that you volunteer. It's good. Right? So my question is there anything in common between 3x squared and minus 2x?
X?
X, right? They have x in common.
Yes, sir.
So tell me, what by x would give me back 3x squared?
One?
Now,
X.
1 by x is x.
Oh, sorry. 3.
Okay, 3 by x is 3x. I need to get back x squared.
Oh, okay.
So remind me, what does x squared mean again?
X by itself.
So if I already have one of the x's, what I need to put here to get back x squared?
X.
Yeah, 3x. You understand?
Yes, sir.
Okay. And if I pull out the x from negative 2x, right? What would I write here?
Minus 1.
Minus 1. Now, you're pulling out the x from this.
Oh. Minus 2.
Yeah. I watch. X by 3x is 3x squared. X by minus 2, minus 2x.
Okay.
If it's almost minus 1, I'll get back minus 1x. Right? Okay. Now, this is where things going to get tricky, yeah? So where things going to get tricky. So instead of pulling out a positive this time, because I'm going to show you something, right? Process. I'm going to show you something. For this to work out, you see how we get 3x minus 2 here?
Yes, sir.
We need to get 3x minus 2 here as well. So, here's the thing, right? What by 3x given negative 9x? What by 3 would give you back -9?
-3.
Yeah. And let's see if that's the right thing to use. So -3 by 3x is -9x, yeah?
Yes.
And what is -3 by -2?
+6.
Right. So you see, the little hack share, right? If you know you're supposed to get 3x minus 2 here, then you're supposed to get that over here. And then you could just figure out where you had to multiply by on the outside.
That actually saw it enough because I was thinking about the +3 all the time.
Oh, it would. Right. So guys, that's essentially it for the types of factorization you need to do at this level. Right. And so now we're finished with this question answer. But now after this, I'm going to move on to a mixed factorization exercise. Somebody said they wanted to see when to utilize each one. So I want you to say your name just shortly, right? Say your name because we're going to go through all of it. All right, so Perseus. Are you seeing anything in common between these two terms?
Yes, so 3x minus 2
Right, and
and x minus 3.
awesome. So that's it,
Yes, yes, sir.
right? Nice. So now I'm going to move on to like a mixed exercise. Right, so somebody was asking me, okay, when do I know which one to use? Right, sure. Let's look at that. So x squared minus 9 plus 3x. All right. Okay. So let's go. So who here wanted to do the mix exercise with me? And they wanted to know when, okay, this is actually trickier because it's going to test multiple ways of factorizing, multiple ways. So who wants to volunteer? Do I have any volunteers? That's the question. Priscilla, say that.
Yes, sir.
All right, so Priscilla, I will try question one, right? Now, if you look at question one, it kind of looks like a what?
Okay.
A what?
Like a quadratic.
Yeah, so let me see if we can at least rearrange it. So if I were to rearrange this, it would turn to x squared plus 3x minus 9. Yeah or no?
Yes, sir.
Yeah, it essentially looks like a quadratic. So to factorize this, I'm going to open up two big pair of brackets. Now, to get x squared, I'll write x by x. Now, what is my last term over here?
Last term is 9, -9.
Right. So how could I multiply to get -9, but add to get +3? That's my question.
Ooh. Positive and negative.
Right.
So
So
they
it's
don't
going to be a positive and a negative, right? For sure. For sure. How am I going to multiply to get 9? To get -9?
3 and 3.
3 and 3. That wouldn't work out.
No. Hmm.
I wonder,
Sunshine.
I wonder if it's a
Check.
faulty question. Wait, I think this is a faulty question. Yeah, looking.
Yeah, so no, we don't really have that many numbers that I could multiply to get 9 and add to get back 3.
Yeah, this is a faulty question. Right? Yeah. Right. Let me rectify this question. What could I do to so minus? All right. So let me just change this quickly. All right, so process, I should be able to figure it out now.
One and nine. One and nine. Sir.
Right.
1 by 9.
1 and 9, right? So I'm
Yes,
going to put +1 here and +9. So guys, if you don't know if you are not sure about when to factorize, whether or not you factorize in a quadratic, look for an expression where the highest power is 2, then the highest power is 1, then they end up with a number. So like x squared plus 9 plus 10x, they try to trick you here. But if you rearrange it, you'll see that it's in the form of a quadratic. And the form of a quadratic is ax squared plus bx plus c. Right, ax squared plus bx plus c. Right. So Priscilla, you okay with this one?
Yes, sir.
All right, cool. Aaron, how would I factorize this?
So is it 2y? Oh, sorry.
Nah, this one tricky, yeah? This one a little tricky. Take your time.
Um, 2 open brackets y squared minus 9.
Okay, is that your final answer?
Yeah.
Nah. Mark that question. What could you do with what's on the inside?
Or
Think about it carefully.
or you could factorize it even more.
Yeah, minus. Okay, so 9 is the same thing as what?
9 same thing as 3 squared.
Yeah, and on the inside you would end up with a difference of
Yeah,
a difference of what?
2 squares.
Correct. So I'll write 2. Mm-hmm.
Y plus 3. Y minus 3.
Awesome. So if this question would have been with 3 marks, I probably get 1 mark. And
Yeah, I most likely would have stopped at y squared minus 3 squared.
they had to think. Yeah, they had to think a little more, right? Okay.
Yeah.
So Aaron, let's look at this question now. This looks like it's a what?
Our quadratics.
For sure, right? That's a quadratic. Now, I'm going to open up 2 big brackets. What am I going to put in this bracket?
A.
In this bracket,
A.
right? And how am I going to get 9?
You'll have to find 2 numbers that when multiplied will give you 9.
Right. What are those 2 numbers you're thinking of?
3, so well, yeah.
Right, we want to get -6, eh? Want to get -6. So how could you? So because if you add 3 and 3, you're going to get +6, eh?
Yeah.
So remind me, other than a positive or a positive, what's the other way you can get a positive?
What's it?
So over here, you have +3 by +3. That's not the only way you can get +9, though.
You could get a positive by adding a negative and a negative.
No, that's not what I'm thinking. So remind me, a positive by a positive is a positive. What else is a positive?
Yeah.
a negative by a negative,
Yeah.
a negative by a negative. So if I write negative 3 minus 3, so negative 3, negative 3, tell me, would I give
And
you negative,
negative 3 by negative 3, you'll still get positive 9, so
right? And if you add negative 3 to negative 3, we're going
negative 6. So
yes. So it's going to be negative 3 here and negative 3 here. Let me know if you understand that.
yeah, so
Awesome. All right. So with this one, how do you think you should factorize this?
3m open brackets m minus 4.
Yes, because 3m by m, right? The m by the m would give you back the m squared, correct?
Mhm.
Then you have positive 3 by negative 4, right? So negative 12m. Excellent. So this one, you're gonna rackle your brain, right? So I'm gonna raffle your brain a little bit. Yeah. Darius, you wanna help me with this one?
Sure.
Let me hear Darius. So, what are you thinking?
Um, give me a second, give me a second. So you have these squares here. So difference between two squares.
Yeah. But before I could do difference on two squares, right? What way do I need to write
Yeah,
it?
square root them.
So I write 4 as what?
Um, 2.
Right, I'll write 4 as 2 squared. So 2 squared by p squared, right? Minus open bracket q plus 2 squared. So if I have 2 squared, p squared, I can write that whole thing as
2p minus q2, q plus 2, and then 2p plus q plus 2.
yeah, that's correct. Right? So I can write 2 squared, p squared as 2p in bracket squared, right? Minus q plus 2, all squared. And now it's in differential squares form, right? This is acting like A and this is acting like B, this entire thing. So it's going to be 2p, right? Plus q plus 2, right? And then it's going to be 2p minus q plus 2. How much of you guys think you'll figure out the last question? So that's a little tricky.
So I think I might leave that one out.
Okay.
Yeah, I will like it.
That was going to be blank.
It's a little tricky. But I want you to recognize that 4p squared, right? Aaron, 4p squared, and you can write 4 as a perfect square.
Yeah, it could be broken down into 2 squared.
Right. So this could be a square term, and it's in a minus. And then this is a square term. Difference of
2 squares.
exactly. Right? Nice. So you're feeling a little better about factorization now?
Yeah, so
So,
So I have a question.
Sure, guys.
Do you by chance have a worksheet for algebra?
Yes, it's supposed to be here somewhere. Right? I do have a worksheet.
You could also send one for geometry and trigs.
Sure, no problem.
Okay, great.
so when you're done there, you could check note number 5 and that worksheet. So,
Sure, no problem. Number 5, you're in trouble.
yeah. Brackets only. The ones I do already. I confuse it.
Send my picture. Darius, send my picture.
You want me to send you a picture?
Yes, send my picture. I'm gonna see what you did.
So for this one,
Yeah, for the question, you say it was giving you trouble.
right? So
Right. And yeah, guys, let's check out our past paper now. So let's check out June 2025 and see the algebra questions there. All right. All right. So Darius, if I move on, let me just check what you have here. Guide you accordingly. Right. So question forward completing the table.
now, sir, I finished at number 5.
The values of the table below represent a function. Identify the rule and express it in form f of x is equal to ax plus b. Right. So you're saying, right. So let's check it out, right? So you're starting off with -1, right? And if you put that into the function, you get an 1, right? So I would actually solve this two in simultaneous equations. Let me explain something. Check this out. So Darius, f of x here is what? What is f of x here?
1
Right? So I'm going to say 1, right? And what is the value for x here? That is giving me the output of 1,
minus 1.
right? So I'm going to say 1 is equal to a by -1 plus b. Does that confuse you?
Oh no,
So you understand that f of x here is 1.
right?
The value for x that's giving you that is -1. So you're going to end up with 1 is equal to negative a plus b. Yeah or no?
No, that's what I line.
I'll say what that's.
Yeah, with the second line.
Okay. What is a by -1?
Negative 1.
-1a.
Okay.
Okay. Okay. Mark that question. Or a by 2b.
2a.
All right. So we think a by -1 will be.
Negative 1a.
That's it. -1a. So 1 is just equal to negative a, -1a. If you don't see the 1, it's understood to be -1a, right?
Right.
Plus b. You're still
This
lost.
is
I mean, if you're still confused by this. Now here
no,
what
so,
Darius?
so you just put it in the same format that I give it there.
Exactly, because let me explain something. This represents the input and this represents the output of the function. Now, all of these values must follow this function. A function is just a relationship that links the input to the output. And as you can see, we have two unknowns, a and b. So you could pick any two and solve simultaneously. So let's try another one. You'll see where I'm going with this. What about 0, 4? For that case, what is x?
X would be 0,
And f of x would be?
4.
So watch this, right? Watch this carefully. I'm going to put it into this. What is f of x?
F of x is 4,
Right?
and then equals to a4 plus b.
Now, what is x?
Oh, A is 0 plus B.
A by 0 plus B. Where's A by 0?
0.
So B is what? A would be equal to
4.
right. And if I know B is equal to 4, isn't it possible for me to go and plug it in here to find for A?
Yes, sir.
So if I know B is 4, what am I going to write in now? 1 is equal to?
1 is equal to minus A plus 4.
Exactly. I want to find for A, right? So I'll move across everything that is not E. So I'll take 4 and I'll move it across. I'm going to end up with 1 minus 4 is equal to negative A. Yes or no?
Yes, sir.
Where's 1 minus 4?
Minus 3.
So minus 3 is equal to negative A. Then you'll multiply both sides by negative 1 or divide both sides by negative 1. Either one is fine. So you'll end up with A is equal to
3.
yeah, 3. So that's the answer. So f of x would be equal to 3x plus 4. And if you don't believe me, check this, right? So when x is minus 1, right, that'll be 3 by minus 1 plus 4. What is 3 by minus 1?
Minus 3.
What's minus 3 plus 4?
Minus 3.
Now, minus 3 plus 4.
No, 1.
1. Can you see that when x is minus 1, you get the output 1?
Yes, sir.
Let me try it with 2 and 10 and see if it works out. Right? So when x is 2, we're supposed to get? When x is 2, what are we supposed to get?
10.
10. So what? 3 by 2 plus 4. 3 by 2 is?
6.
6 plus 4 is?
10.
Bam.
Okay, sir.
I already put some nice questions into this worksheet. I really had some
And
questions.
wait, but sir, I don't know if my way correct, but I didn't like do none of that. I don't know if you see what, because I basically get the same answers, but I don't know if it's the correct like way I approach it.
And that's fine. That's fine. You did it like it looked, you know those let me show you the questions I'm talking about. This is how you answered it. You answered it like this. You know those pattern and recognition questions? That's how you answered it. You answered it like this.
Yeah,
Yeah, which is fine. That's fine. Right?
but I would lose marks like as I would not really like nerdy.
No, that's fine. That's fine. The only thing I would tell you, right? I didn't see you write the final thing properly. So you
Yeah,
should
because I
just,
wasn't sure if it was correct.
if you want to see if it's correct, just make sure that the values there obeys the function that you create. Right? So see how I check
Okay,
it
sir.
back. See how I check it back
Yes,
and
sir.
just do that.
Okay,
Right?
sir.
So guys, let's do some algebra questions here. So who wants to help me with this question? Let me hear. Who wants to help me with this question? Do I have any takers? So we're starting off with xy squared minus x squared y. Salma, guys, do we have any takers?
I could try.
Sure, no problem. So what are you seeing in common, right, between xy squared and x squared y?
The x and y, sir.
Yeah, I'm seeing x and y common in both. So we could factor out xy. If I do that, right, what do I have to multiply by xy to get back xy squared?
Y, sir.
Right, because we already have x and we already have one of the y's. So we're just missing the other y to get back y squared. Does that make sense?
Yes, sir.
All right. And over here now it's going to be minus. And what would I multiply by xy to get back x squared y? We already have
X, just x, sir.
just x. Is there any of you guys here that did not understand how we did that? At all? Tell me.
No, sir.
No, sir.
Do you guys understand that over here we have, so okay, over here we have an x being multiplied by a y by a y. Over here, we have x by x being multiplied by y. If you look at it, we have two y's over here. We have two y's. And over here, we have one y. So we have a y common in both of them, right? Over here, you have two x's. And over here, you have one x's. So in other words, you have a x common in both. And you have a y common in both. So you pull out the xy. And if you pull out the xy to get back y squared, you'll have to put a y here. So y by y will give you back the y squared. If you want to get back the x squared term here, you have to put an x here because x by x is, what is x by x?
X squared.
Right. Awesome. Now over here, we have a quadratic whose coefficient for x squared is not equal to 1. So we'll have to resort to the AC method. First things first, guys, what is A, B, and C? Somebody tell me, what is A, B, and C?
3 is A, X is B.
Nah.
One's a 1.
Oh. And what is C?
10.
Nah, take your time. No, not 10. It's not 10.
Minus 10.
Yeah, minus 10. So you're going to multiply A by C, right? What is A by C?
Negative 30, so
Negative 30. So how could you multiply to get negative 30, but add to get plus 1? That's the question.
6 minus 5, so
Okay, you figured that one out fast. That was really impressive, right? And if you add 6 and minus 5 in a calculator, or if you just simply say 6 minus 5, what will you get?
positive 1, so
Exactly right. All right? Yeah. Awesome. So guys, we okay with that? Yes or no?
yeah,
Okay,
so
Yes, sir.
right. So guys, here we're doing this, right? You're gonna multiply A by C. We get minus 30. How could you multiply to get minus 30, but add to get plus 1? That is the question. So Aaron came up with 6 by minus 5. Guys, what is 6 minus 5? It's not your question, guys. What's 6 minus 5?
Minus
Positive
13.
1.
1, right? So we get back to minus 30 and we're getting back to 1. So great job, Aaron. All right, so Aaron, now we're going to split x into what?
we're going to split it into like difference of two squares, so
Now, not difference of two squares. I'm just going to split it, right? I'm just going to split it. So I write
okay.
Put in 3x squared plus
6x, right? Minus
negative 5,
x,
negative 10.
right? Now, so we're going to split this in half, right? So between 3x squared and 6x, are you all seeing anything in common?
Yeah, so 3x,
Yeah, 3x. So if I factor out 3x from 3x squared, what would I multiply to get back the x squared,
x,
right? And what would I need to multiply to get back 6x,
2, so
right? And here it is. That's a go-to hack. If you do it correctly, you know what? You're supposed to get back x plus 2. Aaron, you see where I'm going with this?
yeah, so
Watch, I'm going to write back x plus 2. Now you tell me, what would I have to multiply by x to get back minus 5x? Even simpler, Aaron.
minus 5, so
And even simpler, Aaron. What by 2 is minus 10?
minus 5, so
You see how easy? Bam, watch that. You see anything in common there?
yeah, x plus 2, so
Right. And in brackets, we're going to write
3x minus 5.
simple. I mean, if you understand that.
Yeah, so
What about the rest of you guys? Do you understand that? Are you wasting no so far? So real far, boy. I feel like everybody just real tired, boy. But listen to one.
Yes, sir.
So
Oh,
Sundays are resting.
oh, boy. Come to your laptop. Oh, they look cool. Say.
Everyone looking like how I feeling right now with these questions.
Check that one. Stone face, like. All right. So, guys, we're gonna presume that we're okay with this question, right? We go with this one. So this is where things gonna get a little tricky, right? Little. So over here we have 4 to the power n divided by 4 to the power 3 is equal to a quarter. Now I can tell you the answer one time, right? But I won't. Guys, if you want to get a quarter, right, let's look at a simple hypothetical example. So there are multiple ways you could do this. Let's look at a practical approach. Guys, imagine if I had 4 by 4 all over 4 by 4 by 4. What happened there?
You cancel out and then you'll get
You could
quarter.
cancel out the 4/4.
And I'll get a quarter, and
Yeah.
so like generally speaking, on top it would be 4 squared, yeah?
Mm-hmm.
And then the bottom would be 4 to the power 3, and
Yes, sir.
okay, so maybe let me try to do that with 4 by 4 by 4 by 4. As you can see, we have 4 to the power 4 on top, and we have 4 to the power 5 on the bottom. We're gonna end up with
A quarter.
again. So like 4 to the power 4 all over 4 to the power 5 is a quarter. Are you all seeing a pattern?
Yes, sir.
Yes,
Yeah.
sir.
If you have 4 to the power n all over 4 to the power n plus 1, don't let the n confuse you. It's just like an arbitrary number, right? So like whatever n is on top, if the number in the bottom is 1 more, right? You get a quarter. So question, right? I could write 4 to the power n divided by 4 to the power 3 as 4 to the power n divided by 4 to the power 3. I can do that if I wanted. So according to this, right? What do you think n would have to be? Somebody tell me. Look at the examples.
4.
2, sir.
2. 2. The answer is 2. You'll see why I'm saying that shortly. This wasn't the only way you could answer the question. Eh? It's just like a logical way to look at it. It's a 2-mark question. Look at this, guys. Tell me, if I have 4 by 4 all over 4 by 4 by 4, what's going to happen?
You'll get a quarter.
Yeah, I'll get a quarter. I'll understand what's going on with this, right? Watch. Over here, they said 4 to the power n divided by 4 to the power 3. So if you want to get a quarter, the number on top would have to be 1 less than 3. Yes or no?
Yes, sir.
But I surely understand that.
Yes, sir. It's straightforward.
I was trying to show you how to do it without bringing hard maths into this. But I'll show you all the other approach, right? But I think it's a lot of things to do for two marks. So guys, I have 4 to the power n divided by 4 to the power 3. Right? And that's equal to a quarter. Just some general rules for indices, right? If I am dividing indices, so if I have a to the power n divided by a to the power, let me just say n to the power a divided by n to the power b. If I have that situation and I'm dividing and I have the same bases, you know what I mean? That means that I could minus my powers. Probably wondering why. Let me show you why. If I had 4 by 4 by 4, that's 4 to what power? Tell me, guys, that's 4 to what power?
3/3, sir.
Right. And if I had 4 by 4, that's understood to be 4 to what power?
2.
Right. So 4 to the power 3 all over 4 to the power 2. Wouldn't two of the 4's in the bottom cancel off with 2 on top?
Yes, sir.
Wouldn't that result in 4 to the power 1, which is just 4?
Yeah.
So watch. When you're dividing, you need minus the powers. So watch. 4 to the power 3 minus 2, 4 to the power 1, 4. Understand?
Yeah, sir.
Guys, anytime you divide them and they have the same base, you minus the powers. So in other words, what I'm trying to say is, over here, you're going to end up with 4 to the power n what? So Aaron, do we have the same base here? The base is just a number you're raising to a power.
It'll be 3 minus n.
Nah, it wouldn't be 3 minus n. Look at it again, right? Let me look at a practical example again.
It'll be n minus 3, sir.
Yeah, it would. Look at this, right? On top, and you have 4 to the power 3, and then the
Yeah.
bottom, you have 4 to the power 2.
Yeah.
Watch. That would work out to be 4 to the power 3 minus 2, which is just 4 to the power 1, which is just 4. Watch. And if you do the long working, wouldn't 2 of the 4s cancel off with 2 on top?
Yeah.
So wouldn't that just leave it with 4 to the power 1, which is just 4?
Yeah.
Yeah. So if you're dividing, right, you're going to, the one you're dividing by is going to turn to a negative, you're going to minus. So 4 to the power 3 minus 2. So in this case, 4 to the power n minus 3. Are you understand?
Yeah, sir.
All right, and let me explain something. You see how we have our quarter, right? This is understood to be 4 to what power?
4 to the power negative 1, sir.
Not so fast. Yes, you're correct, but take it one step at a time. This is understood to be 4 to the power 1. Now, if I take 4 to the power 1 and I bring it up to the top, that 4 to the power 1 is going to turn to 4 to the power what?
Negative 1, sir.
Exactly. Do we have the same base now? Yeah, we have the same base, 4. It's actually a odd maths approach. If you do it, you'll get full marks. This is one of the instances where you get full marks. So once I have the same base, I could equate the powers. So I could now say n minus 3 is equal to minus 1. And from here, I can solve for n. So if I move across minus 3, what would minus 3 turn to?
Positive 3, sir.
Exactly. You then put n is equal to minus 1 plus 3. What is minus 1 plus 3?
Positive 2, sir.
Exactly. Positive 2. So you see n is equal to 2. That's how you would solve it like hardcore mathematical. So yeah, again, let me run through the steps, right? Guys, can we see that you have the same base, 4 and 4? Yes or no?
Yes, sir.
Yeah, sir.
We are dividing. If you're dividing, you're going to do what with the powers? Add the powers or subtract the powers?
Subtract.
Right. So that's going to turn to n minus 3. We have a quarter. This 4 is understood to be raised to the power 1, right? So you're going to take that and bring it up to the top. If you take something and bring it up to the top, the sign for the power is going to change. That 4 to the power 1 is going to turn to 4 to the power minus 1. Then, can we all see that they had the same base now? Doesn't
So it cancels out.
Yeah. And even better way to look at it, the bases are the same, so we could literally equate the powers. Why? Aaron, if this is equal to this, right? If the bases are the same, and the powers are to be the same,
Yeah.
think about it, right? If I put in 2 into this, 2 minus 3 will work out to be what?
Negative 1.
You see how everything working out? Watch. This whole thing will just be 4 to the power minus 1, which is equal to that. Makes sense, right?
Yeah.
Yeah. So that's how you work this question out. It's easier approach, right? This is the more mathematical approach. You all understand this question? 2-mark question.
Yes, sir. I get it now.
Right? What if I said 8 to the power n divided? So watch this, eh? Let me see what I really get it. If I said 8 to the power n divided by 8 to the power 19 is equal to 1 over 8, what would you tell me n is? You don't do any working. Like you could look around and figure it out. How would you tell me 8 is? I mean n is? You know the answer?
Is it 18, sir?
Yeah. Oh, yeah. Whoop, whoop, wake up. You. Yes. Yeah. And let me understand why, eh? Because you'd have 18 eights on top and you'd have 19 nines, 19 eights in the bottom. Wouldn't 18, wouldn't 18 on top cancel off with 18 in the bottom?
Yeah,
That would leave you with how much eights in the bottom?
1/8.
Makes sense, right?
So I think I would have done the add math work in for the question like this instead of drawing 18 eighths and 19 eighths.
No, but you don't have to. You don't have to, right? What? Let me see if I really understand. So what if now I said 7 to the power 16 divided by 7 to the power n is equal to 1 over 7? What would you all say the answer is?
15.
Nah, it wouldn't be 15.
I think I'll need some practice on this one.
Let me explain this, right? So Perseus.
Minus 17.
Nah, it wouldn't be minus 17, it would be positive 17. Let me explain something, right? If it's 7 to the power 16 on top, right? How much sevens you would have on top?
16.
16.
You have 16, right? So 16. And how much sevens? Like, if you want to get 1 over 7, right? You want how much sevens to remain in the bottom?
7.
Nah, 1 7. Watch.
7.
Let me try to understand this. So you have 7 right there. Can I go and draw 7? Guys, you would have, so 7 to the power 16 means that you're going to have how much sevens on top? 7. Tell me, guys, if it's
16.
16 sevens, right? 16. So I have 16. And according to the answer, I want how much sevens to remain in the bottom. How much sevens are you seeing here?
7.
Not 7. I see 1 7.
Yeah, 1.
1 7. 1 7. So the marks on that question. If I have 16 sevens on top, how much 17 do you think I should have in the bottom so that I remember 1 7 in, in denominator?
17.
17.
Yes, because 16 and the ones on top, when I cancel off with 16 in the bottom, and that'll leave you with 1 7. Crazy, right? Yeah,
Yes, sir.
it's all right. Nice. Nice. Awesome. So let's move on now. So the algebra questions could also come like this, right? So we covered factorization and how they could bring that, right? They will all, like I noticed as of recent times, they are bringing shapes, right? And they are assigning variables to the lengths. And you need to come up with equations and solve them. All of that is part of the algebra. So who wants to do this question with me? Any brave souls?
So, I'll try.
As proper say as a proud I am, I never hear you talk so much like a real volunteer. I like that. So, Perseus, get the question I read for now.
So I can't even see that properly, but okay. The lengths of three sides of a trapezium are shown on the diagram below. The area of the trapezium is 750 square units.
Right? So, let me ask that question, right, guys? In these algebra questions, you could only solve it if you have how much unknowns? Tell me, guys. You could only solve that equation if you have how much unknowns? Does anybody know? Maybe I might have to give like a funny example. I'm going to see it. What an example they like. Okay, I'll show, I'll bounce understand this example, right? So, guys, let me just say, right, that something happened here, and like, I have two unknowns. Who would be the father, right? If you have two unknowns, right? How are you gonna figure out who's the father? How are you gonna do that?
Yeah, that go by process of elimination.
That's why I saying, yeah, yada yada yada. Yes, like for me, I see how Goldstein and things, so it looking like he's Prakash's son. You know what I mean? But what I'm saying is, in algebra, right, and in any equation you make, you could only solve it if there's one unknown. If there's more than one unknown, you'll have to solve simultaneously. And don't worry, we will cover simultaneous equations tonight. And I want to also cover some proportionality. Do you know about proportionality? Like with the constant k and whatnot? Yes or no?
Nah.
So I can't remember now. My brain is blank.
Okay. So the point is, with these algebra questions, you need to look out for information to come up with an equation, right, with one unknown. So Perseus, just by reading this, they're telling us that the area is,
750 square units.
right, keep that in mind, right? And what do they want us to do in the first part?
Write down an expression in terms of P and Q for the area of the trapezium.
How would you find the area of a trapezium? What's the formula for that? And before you tell me you don't know, I would tell you that, in the exam, in the formula sheet, well, I'm actually not sure how they're gonna go. I'm not sure how they're gonna go at all. Because they're gonna give a little laptop or like some computer. It's weird. I don't know why they're changing up everything so. But they will give a formula sheet somehow. And this formula is in the formula sheet. But anyways, Perseus, you know the formula for area of a trapezium?
I know, sir. I forget everything.
All right, so the formula for area of a trapezium, right? First things first, you need to define three things. The height. When I talk about height, I'm talking about this height, not this height. That's not even a height, that's a slant length. Then I'm talking about the two parallel lengths. So I'll call this one A, I'll call this B. Right, so the formula for area of a trapezium is equal to a half A plus B by height. Some of you all might have seen A plus B by H over 2. These things are the exact same thing, right? Exact same thing. So guys, when you look at, so Priscilla, when you look at this question, right? When you look at this question, first things first, tell me, what is the area? What is the area they're telling us?
The area of the trapezium.
Yeah, what are they telling us that is?
Half open bracket A plus B close bracket E.
No, 750. So that's the area.
Oh my gosh.
But in the first part, they just want an expression. So you're not going to make an equation, just an expression, right? You all know that an expression is just something without an equal sign. Did you all know that? If it's not equal to anything, it's an expression, right? So let's figure that expression out. So you're probably saying have an equal sign here. There's a difference. So I'll show you. So it's going to be a half. Somebody tell me what A is.
Is 4P.
B is?
B is 3Q.
Right, and H is?
H is 6P.
All right. So let me ask you a question, right? Is it okay for me to say a half by 6P? Is that legal? If I say a half by 6P.
Yeah, so
Yes, sir.
Yeah, that's actually legal, right? Because I'm multiplying everything here. So what's a half of 6p?
3p, sir.
Three.
All right, so you're going to put 3p by 4p plus 3q. Now, when we do in algebra, you need to be able to know how to expand the brackets, right? So that 3p on the outside is going to multiply by all the terms on the inside. So what is 3p by 4p?
12p squared, sir.
12p squared.
What is 3p by 3q?
9pq.
I mean p cubes. 9.
You guys understand this? Yes or no?
Yes, sir.
So your answer is just simply 12p squared plus 9pq. Did you see me put that equal to anything?
No, sir.
No, because it asks us for an expression. Are you okay with that? Let me know if you guys.
Yes, sir.
All right, cool. So given that q is equal to 2p, determine the value of p. So they're asking us to find for something. If you want to find for something, more than likely you need to come up with an equation. You'll need to come up with an equation if you need to find for something. So guys, what do we know 12p squared plus 9pq is equal to? That's the area, right? What was the area equal to?
750.
750, right? And they're telling us that q is equal to
2p.
Okay.
So anywhere that I see, okay, before I say anything, how much unknowns are there seen in this question? Those say three, yeah?
Four,
Four.
sir.
No, I see in two. I see
Because
P and Q.
Q.
P and
Right.
Q.
So there's a problem there. Remember? Like, who is the father? Like, who is the father? Right? It's a big
So
problem.
you create that?
I make a whole TikTok video explaining simultaneous equations. You're sticking, you're sticking. I think I sent that. Yeah. I draw this. I actually draw this. Watch. Oh no. This is my lost it. Oh no, I get it back. Cool. I get scared. I will send all the documents out for simultaneous equations as well. Right? All right. Yeah. So Q is equal to 2p. So anywhere that I see Q, what am I going to write? Somebody tell me. Anywhere I see Q, what am I going to write? According to what they told us, anywhere I see Q, what am I going to write? Q is equal to what?
2p.
Right.
2p.
So anywhere I see Q, guys, instead of writing Q, I'm going to replace it with 2p because they are equal. So I'm going to write 12p squared plus 9p, and I'm replacing Q with
2p.
right. And that'll be equal to
750.
right. So we're going to end up with 12p squared, right? What is 9p by 2p?
18p squared.
Are these like terms?
Yeah, sir.
Yeah. So what is, imagine you had 12p squared, right? And then you add 18p squared state. How much p squared do you have now?
30.
Right, so 30p squares. Is there anybody that was really confused by that?
No, sir.
Guys, I have a question. If I had like a random p term over here to the side, would I be able to add that to the p squared term or not? Question is p the same thing as p squared? Is it the exact same thing?
No.
No. So you can't do that. Remember, it's like different species. One is like a dog and one is like a parrot. No, me do them. You can't mix, right? Has to be the exact same thing for you to combine. So guys, watch. If I had 12p squared, I'd literally have 12p squared. Why not gonna write all that? And if I had 18p squared, I'd literally have 18p squared. So like I combine them to get 30. Are you okay with everything so far?
Yeah, sir.
Right. So what I need to do now, I need to find for 1p squared. So how would I find for 1p squared?
You have to carry 30 over to the other side and divide it. Divide them by 30, so both sides by 30.
Exactly. 30 could go into 750 how much times?
25, sir.
Right? And you should be smiling. It's real easy. What
Uh,
would you find for p?
you'd have to do the square root, sir. Square root
Right. So,
of 25, which is 5.
yep. Oh my God. Good notes. Right? Right. And you will need the units we're using here is units, right? Literally units. So you'll write 5 units. All right. Did you all understand how I came up with the equation to begin with? Yes or no? Let me know,
Mhm.
guys. Like, do you all know why?
Yes, I got it.
Do you all know why I put it equal to 750 or not? Okay, I put it equal to 750 because they said that was the area. And in first part, we actually found the area to be 12p squared plus 9p cubed. So we put it equal to each other because this is the area and and we know the area is 750. So that's how I came up with that equation. And it told us that q was equal to 2p. So I made a substitution. So whenever I saw q, I wrote 2p instead. And then I simplified, made p the subject, and I got 5. Are you all okay?
Yeah, sir.
Yes, sir.
All right, what if they asked you to find the value of q? What would you say?
Since we know that P is now equal to 5, sir, and we know that Q is equal to 2P, it'll be Q is equal to 2 by multiplied by 5, which is equal to 10, sir.
And how could I check if my whole answer is correct?
You could replace anytime in the equation, anytime you see a P or Q, you could replace it with the actual numbers it's supposed to be.
Right, so that'll be 12 by 5 squared, right? Plus 9 by p. 9 is like 5, right? Q is 10. So plug that into your calculator and eliminate if you get back the 750. So 25 by 12, right? 9 by 5, right? That'll be 50, 50.
Yes, I get it.
How about the rest of you guys? Are you all getting the 750? All right. So you're supposed to get 750. Right, so Aaron, how you feeling about the algebra question that they brought in 2025 June?
Uh, I think I'm able to understand them now, sir.
Okay, well, that's great. That's great. What about the rest of you guys? Yes or no?
Yeah.
Well, hear what? Hear what? You can do a question, all right? You can do a question. Stay on muted. You do a question. Some nice questions in this here, boy. Love this, boy. Nice. So factorize each of the following algebraic expressions completely. So over here, we have x squared minus 49. All right, so guys, tell me, is that explicitly in complete any square form, we add it to something.
You had to,
What's incomplete any square form? Difference of two squares form, my God.
nah, you had to like factorize it some more.
Right, now factorize it somehow. You had to change a little bit. Like, let me ask you that question, right? You see now squared over here, then minus. Could I write 49 as a square?
7,
49 is the same thing as 7, 1.
7 squared.
So can you see that is a difference of two squares?
Yeah,
Right. And if you're confused, watch x squared minus 7 squared. Difference of two squares. Right? Just to remind you what the difference of squares looks like. It's if you have something in the form a squared minus b squared, and you factorize that, you're going to get a plus b by a minus b, right? Tell me if you understand that.
yeah.
All right. So what is a and b here?
A would be x
Right? And
and B would be 7.
right. So you tell me what to write inside the brackets.
X plus 7 and x minus 7.
Nice. You understand it?
Yeah,
Awesome. Now we have to factorize a quadratic. So I'm going to open up two big brackets. Now the coefficient here for x squared is 1. So I'm not going to use the AC method. I'm just going to use the shortcut method I showed you guys. So guys, what's the last term over here? What is the last term?
35. Oh, sorry,
Right.
negative 35.
Yeah, negative 35, right, guys? Negative 35. So here's my question. How could you multiply to get 9 minus 35, right? But add to get plus 2.
7 by negative 5.
Okay, do you all agree with that? If you multiply 7 by minus 5, what are you going to get?
Negative 35.
Negative 35.
Only 7 minus 5.
Positive 2.
Guys, did he cook?
Yes, sir.
yeah.
Yeah, he cooked. Right? So the answer is just x plus 7, right? And you tell me what to put in the other bracket.
X minus 5, sir.
Yeah. Nice. 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 Right. Now they are saying, hence simplify the expression. So remind me, guys, before you can simplify, you need to write everything as a product of their factors. So factorized version. What did we say x squared minus 49 was?
X plus 7, x minus 7.
Yeah. X plus 7, x minus 7. And what did we say the denominator was?
X plus 7, x minus 5.
Are you all seeing anything that could potentially cancel off?
X plus 7, so on both of them they cancel off.
Do you all agree with that?
Yes, sir.
Now, some students is making this mistake, and I want to know if you would make this mistake as well. Some students might cancel off the x and the x. Do you do that?
Yeah, I would have do that, sir.
I don't think I would have do that, sir.
I do
No,
that, you know.
I would have do that if I wasn't doing the scratch balls.
It seems kind of logical.
No. Something I would have.
I think I might have just leave it as x minus 7 over x minus 5.
That's correct. That's correct.
Oh,
Guys, let me explain what I'm wrong, huh? Let me explain. Let me show you something, right? Let me look at a logical example first, right? First things first. What is the opposite of multiplication?
division.
Division, right? And furthermore, right, x minus 7 is actually a term by itself, and x minus 5 is a term by itself. Now, you can think of it like this. X in a relationship with 7, right? See that sign in the middle? That means in a relationship. You can't just, guys, it can't just be like Terrence I don't know who Terrence is. But you can't just be nah. If you're in a relationship, you can't do anything, right? But I'll give all you a more mathematical, like a more for mathematical explanation. Let's say x was equal to say 9, right? If x was 9, guys, and it would be 9 minus 7 all over 9 minus 5, or like a confusion here. If x was say 9, wouldn't this be the
Yeah,
case?
it would be 9 minus 7 over 9 minus 5.
Everybody with me? 9 minus 7 over 9 minus 5, right? If x was 9. Yeah or no?
Yeah,
I'm not hearing
Yes,
from
sir.
anybody else at all.
Yeah.
Okay, guys, if you wanted to work this out, wouldn't you simplify the top and the bottom first?
yeah, you'd minus them.
Where's 9 minus 7?
2,
2, and where's 9 minus 5?
4.
Will you be like a man and say minus 7 over minus 5?
No, sir.
No.
No, right?
All right, I understand it. No, sir.
The reason for this is because here they say you have to work your numerator first and you have to work your denominator secondly, right? The point I'm trying to make is this is a whole term by itself. So you would see people typically writing these things in brackets. And the brackets is there so you wouldn't be like a mad person and do this. Right? And illegal. Say it. And illegal. Right? You can't do that. And this is the reason again. And if you work in this again, guys, and you would simplify this first to get 2, then you would simplify this to get 4, and then you would divide, you get half.
Yeah, sir.
Yes, sir.
Yeah, you're not gonna just cancel. No. What you doing? Yeah. That 9
You
minus
can
7 is a term by itself. As a
if you
term by
can't if you can't if you cancel the nines, you'll end up with negative 7 over negative 5.
just 7 over 5. That not that nah. But the correct answer is a half. Understand?
Yeah, sir.
You have to treat the numerator as a separate thing, and you have to treat the denominator as a separate thing. So, guys, this is not legal. I'll make a note about it here in case you're tempted to do it. When you're studying, maybe you might look at these notes and be like, oh, okay, yeah. I'm gonna do that. Right? Please do not do this. If I do that, this is literally going to be me. I'm going to jump. Or they want me to jump,
No, sir.
then don't do that. Oh, yeah, don't do that, right? Yeah, do. Right, so do you understand the final answer? It's just x minus 7 over x minus 5.
Yes, sir.
Yes,
Okay,
sir.
good. It's a good thing I went because I was looking at that, and I was like, someone or them might do that. Like somebody might think to cancel all the x's. You can't do that. Okay.
So could you also write it as like open brackets x minus 7 close brackets open brackets x minus 5 close
Yeah,
brackets?
that's fine. That's fine. That's fine.
Okay.
I put it over here just to show you that well, the numerator is one separate thing, and the denominator is one separate thing. You can't do anything. I have a question though. What if, right? It had like 10 by this and 5 by this. So 10 multiplied by this entire thing and 5 multiplied by this entire thing. Would it be legal for me to now say 5 into 10 is 2? Would that be legal?
No.
Yeah, that's legal.
I thought I would have had to multiply.
Yeah, you could. You could. Yeah, you could. Watch. I'll show you something, right? Again, now we use the same example, right? that'll be 2 by 10. And this could be, you're going to end up with 20 over 20. Okay. Which is just what? 20 over 20 is what?
1, sir.
1.
All right. Let's try to do it differently, right? So what about if we have 10? So 9 minus 7 is 2, right? And 9 minus 5 is 4. Are you with me so far?
Yes, sir.
So I understand that 9 minus 7 is 2. 9 minus 5 is 4. Okay. And I said it's legal, right? So 5 into 5 is 1. 5 into 10 is 2. What's 2 by 2? 2 by 2 is? Or 2 by 2? What's 2 by 2, guys?
4.
And in the bottom, what's 1 by 4?
4.
Did I break the laws of maths or did I get back 1?
Yeah, get back 1.
Yeah, that's legal, right? That's legal. See, yeah, if it was like this, you could say 5 into 5 is 1. Why? Why? Let me understand why. Right? Because if you notice, 5 is multiplying by this entire thing, and 10 is multiplying by this entire thing. In other words, it comes like it's just multiplying the whole expression by 2. Yeah. Because guys, if I'm multiplying this by 10 and I'm dividing this by 5, 5 into 5 is 1, 5 into 10 is 2. It comes like I just multiplying the whole thing by 2. So yeah, if you have a situation like that, you can simplify. So anytime you see a sum or a difference in fractions, you cannot cancel off anything. The only time you could cancel off things for division is when you're multiplying. Okay, are you okay with this?
Yes, sir.
Okay, cool.
Yeah.
Right, rearrange the formula shown below to make M the subject. So guys, if you want to make M the subject, M should be the only thing on this side, yeah? Should be the only thing. Now, there are multiple ways you could go about making it the subject. Multiple ways. I'll show you some of the different ways. But let's go with the most obvious method. If you're trying to make M the subject, M should be the only thing on this side. Is M the only thing on that side right now, as it is?
No, sir. It's being minus by K.
Exactly. So what should I move across then?
K, it should move to the other side.
Okay. Now, guys, I have negative M squared, right? I want to find for M squared first. So what could I do to turn negative M squared to positive M squared? If I had negative 5, what could I do with negative 5 to turn that to positive 5? All right, so guys, question. What is minus 5 by 1?
Minus 5.
We think minus 5 or minus 1 is.
Positive 5.
So we think I could do with minus M squared to get positive M squared. Multiply by?
Negative 1, sir.
Yeah. If I multiply everything by negative 1, that S is going to turn to what? So what?
Negative.
Yeah. If you multiply by negative 1, here, easy way to remember it, right? The signs are just going to change as well. So from positive S, I'm going to turn to what?
Negative S.
From negative K, I'm going to turn to?
Positive K.
Right? And that's going to be equal to M squared. Understand?
Yes, sir.
Right? Now, guys, if you want, you can switch this thing around, right? So I could say M squared is equal to minus S plus K. Did I confuse you all? Or like, nah. Let me know if I confuse you all bad, like big time.
No, sir. That's switched them around.
That's all, right? I just switched that. And now, guys, if I want to find for M, right now I have M squared. What's the opposite of squaring something?
The square root, sir.
Right? So I'll square root both sides. if I square root both sides, the squared and the square root gonna cancel off. And that's gonna leave me with m, yeah?
Yeah.
Oh my god. Oh my oh. I just want to draw a square root, boy. Okay, okay. L square root. Yeah. Yeah, so m is going to be equal to the square root of minus s plus k. And some of you all might be like, well, you might want to ask me, well, sir, would I get my answer wrong if I say m is equal to the square root of k plus k minus s? What do you think?
Um, it's not wrong, sir.
It's not wrong. It's not wrong. It's the same thing. You know why? Box that question, right?
Because minus s plus k is the same thing as k minus s.
Exactly right. And just still have plus k over here, and I
Yeah.
still have minus s over here. So I mean, if you guys understand this question,
Yes, sir, I understand.
how about the rest of you guys?
Yes, sir.
Are they want question like this to do? Yeah or
No.
no? Right? Let me do some questions where we have to make things the subject of the formula. Asking ChatGPT for some questions. To me. Asking it for some hard questions. I think I'm ready for some hard questions. What do you think? Yeah or no?
No.
Ah, you see, that's so sad, boy. Make me feel bad. Make me feel way, boy. Damn. I feel sad with that one. Eh,
Why, sir? You think we had question?
you think CXC gonna spell you?
No.
No. No. I can't follow it. That's why I'm gonna give all some tricky questions.
That like when we parents when I say when we were small, I beating you because because I love you.
I beaten you because I love you. Is the truth, eh? What doesn't kill you makes you stronger. Right, number one. If I have y is equal to 3x plus 5, by the way, it should be seen as the form of a line, right? Just saying. A way to make x the subject. Would you be able to do that? Yeah, asking. Who wants to help me with this question? If anybody would like to. We insolvent for why? We just want to make x the subjects. We solvent for x, if anything.
So
Yeah?
the first thing I think you'll have to do is move the 5 from over here and put it on the other side, becoming
Right.
negative 5.
Because if we're trying to find for x, right? X should be the only thing there.
Yeah, sir.
Yeah. And now we have 3x, but I want to find for 1x, so I have to do on both sides.
You'll have to divide by 3, sir.
So my final answer for x is just
Y minus 5 over 3.
if you didn't understand this at all, tell me.
That's how I get it.
How about the rest of you guys?
I understand.
All right, well, let me look at the harder one. Nice. I see a nice one. I see a nice one. Anybody here do physics?
No.
Me?
That is average velocity. That's the initial plus the final divided by the time you take them. Yeah. Right, so capital V is equal to U plus common V all over T, right? Make U the subject. Right about now, probably feeling the cry, but I promise, sorry. It's not that hard. So who want to help me with this question?
So I think I get it.
Well, would. So how would you do this question?
First I move the T from there underneath and put it across. So if it's dividing by T here, it becomes TV on the other side.
Right? You multiply by T on both sides, right?
And then when you do that, the V on this side, you put it across on the other side, so it becomes minus V.
Right. Excellent. Excellent, man. Okay, so I was somebody that don't know how to do the question to come to me and ask more to do it. That we could run through the question together. So is there somebody that does not know how to do this at all? Adika, you there?
Yes, sir.
Adika, let me try to understand this question, right? So who you want to make the subject here?
You.
The way all I said, boy.
Alright. So you want to make you the subject, right? Okay, so there are multiple ways you could actually do this. I feel like since everybody okay with cross multiplication already, I can show you a way to do with cross multiplication. I'll show you all the different ways you can do it already. So guys, is it illegal if I write capital V all over one? Or not? Tell me that's legal.
No, how do you know?
That legal, sir.
Yeah, that's legal, right? I can write V over one. If you're confused, right? Guys, where's 5 over 1? Matter of fact,
5.
it's 7 over 1.
7.
Guys,
8.
the point is n over 1 is equal to n. Anything over 1 is itself, right? So if I write V over 1, that's fine. That's fine. And I'm breaking any laws I mastered. Right? So I have two fractions and I have a fraction on either side, so I have to cross multiply. If I cross multiply, guys, I want to make U the subject. So I'm going to do the multiplication that involves U first. So guys, what do you think I'm going to do first? V by T or 1 by U plus V?
1 by U plus V.
Right. Where's 1 by anything?
Itself.
So I'll just write 1.
U plus V, sir.
Yeah, I'll just write U plus V. And that'll be equal to what?
TV, sir.
Right? V by T or TV, that's fine. Multiplication is commutatively order, doesn't matter. And I want to find for U now. So what shouldn't be there? If I'm trying to find for U, what should not be there?
VV.
Exactly. Take that V and move it across. Second another U is equal to VT, right? Minus V. Did you understand how I did that?
Yes, sir.
And there was other ways you could do it, right? So like if we okay, I think everybody hates working with fractions, right? Over here we're dividing by T. So to get rid of it, we'll multiply by T on both sides. We'll get VT is equal to U plus V. From here, you just move across the V because you want to find for U, and you get VT is equal to VT minus V is equal to U. And you get the answer one time. There are multiple ways you could work the question. I just show this one because I mean, because I'm doing cross multiplication. I probably know what to do. Is there anybody that didn't understand this at all? Like at all? Like nothing.
It's okay, I'll just take the L. I'll just take the L.
Faith, don't talk like that. Faith, let me do the question again. Faith, eh?
Yeah, but
Wait. Faith, you need to have faith to do this question.
Often does this come?
Say that again.
I say, how often does this come?
Hey, don't talk like that. I don't talk like that. I don't like when you talk like that. It's not that hard. I promise you, it's not that hard. We could do, hear what? Faith, don't lose us 2 marks. You can get us 2 marks. So Faith, tell me Faith. What is it? What do I want to make the subject here? What do I want to make the subject?
The U.
The U, right? Okay. The U. You know how to do cross multiplication by chance?
Yes.
All right. Well, it should be fine. Don't worry yourself. So I could write the V as V over
1.
exactly, and that'll be equal to U plus V all over the T,
T.
right? I'm gonna cross multiply now. So I want to make what is subject here. I can just remind me,
U.
right? So I'm going to do the multiplication. That's gonna have U in it first. So I'm not gonna multiply V by T first or 1 by U plus V.
1 by U plus V.
Okay, and where's 1 by anything?
Itself. So U, V.
Yeah, exactly. U plus V, right? And what is it? That'll just be capital V by T, right? Yes or no?
Yeah.
You want to make the subject
Yeah.
again?
This is the part where I'd probably like get mixed up.
All right, don't worry yourself.
Because why did we put the VT here?
I put the PT over here.
Yes. The cross multiplication.
Then the cross multiplication tie up.
Not really.
So watch. We multiply this, right? And we got U plus V, yeah? Yeah.
Yeah.
And then that would be equal to the other product. V by T,
Okay. Okay.
right? If you had T by V, that's fine as well. That's fine. You okay?
Yeah.
And can we both agree that it's the same thing you've been doing whole lot today?
Yes.
It's the exact same thing.
With just letters.
Yeah.
So
It
I don't
is-
really have a way of confirming if I do it correct.
I know, but it's the same process, right? It's the exact same process,
Yeah.
right? So, sorry, I'll give you a question to do with me just now. But you're trying to find for U. So what should be the only thing on that side? What should be the only thing there?
Why we don't put the U and the V on top and the V and the T to the bottom and cross out the 2 V's?
Whoa. Let me explain why, right? This is a common V. It's a capital V. They could okay, so like in physics, a common letter and a capital letter can mean two different things. Like capital, that means moment, and common, that means mass. So they can represent different quantities. So they're not the same thing,
Okay.
right? So yeah, that's why. They're not the same thing. Right? So I'm trying to make what the subject here. Just remember,
U.
right? So if I want to make U the subject, what should be the only thing on this side? The only thing remaining.
The U alone should remain.
Exactly. What are we adding to U? We're adding something to U. What are we adding to U?
Currently, we add in the V.
So if I want to get rid of it,
Common V.
if I want to get rid of the V, and I would have to take away the V,
Yeah.
that makes sense, right? So you just send it across and I want to take out, I want to minus V. So the answer is just U is equal to VT minus V. What do you think? Insanely difficult, or you think you could actually?
Well, it's not difficult in theory. It just don't make any sense. But I guess I can memorize this formula.
No. If you're talking like that, I wouldn't pass it. It's not about memorization, it's about, and it does make sense. It's just
Yeah, it makes sense.
You're frustrated. Yeah.
No, this doesn't make any sense at all. You
See,
just told me the V cannot. The V and the common V and the capital V is two different V. And now you're taking it away. But all right.
Okay, they represent different quantities. So the capital V could say represent voltage, right? And the common V could say represent velocity. Are those the same thing?
No.
No, they're not the same thing. So I can't divide them. And they wouldn't cancel off. They're two different quantities. So let me try to make a little more sense here, right? 10,000 numbers. I will give she a number just now, but like fit. See what point you okay up to? Like this point you okay up
Now
to?
the max it should be like 10. The max number should be like 10.
But
Baby
like
steps.
right, but like you okay up to this point or not?
Yeah. Okay up to there. And
Right.
then when you start to move the V around.
All right. So you remind me. Wait, is it? Yeah, remind me. What are you adding to the U over here? What are you adding to the U?
The U you add in the common V.
Right. So if I wanted to get
Oh wait. So U, I will say U is 2
right,
and V is 4, which would equal to VT, which means 6.
right. So like
I think I'll have to come up with my own numbers.
so if that is the case, right? What?
Oh, okay.
You understand?
Yeah.
Right? And
Yeah.
then you could take the
So it's just algebra.
yes. All of this is algebra. All
Yeah,
of
I was
this.
getting frightened there for a second.
No, no, no. All of this is the same thing you've been
But this
doing.
was something new.
So watch this, right? Watch this. Watch this, right? Watch this. Right now, U is the unknown, right? U is the unknown. So V could be 4, capital V could be 2, and common T could be 3, yeah?
Mhm.
So like when you solve for this, if you wanted to solve for U, right now you're adding 4 to U. All you need to do to find for U by itself.
Find U, you would have to move the V across the number line to take it away.
Exactly.
Okay.
Yes. Making a lot more sense now?
Yeah, a lot more sense.
And this gonna make plenty sense, right? Watch. If I'm adding 4 to U, can we say that U has 4 extra right now? Like if
U
you
has 4 extra.
think about it like this, right? Think about it like this. Um, is you want to find for U, right? Right now, what is being added to U?
4.
4. Do you understand what I'm saying? Right now, this is actually 4 extra or not?
So U, like U4, like X4.
No.
Is that what you mean?
That'll be multiplication. Let me explain something.
so it's like, say you have a variable, you say, like, let's say you use 2 cookies, and you know, plus 4 more cookies is
Mm-hmm.
so.
All right.
So we just say like U itself is just 2 cookies, and then you have 4 adding to it. So it's 2 cookies plus 4.
I was
So
understanding
extra.
until they overcomplicated it. I'm just gonna move my 4 over to the number line, take it away, and get my answer for you, making you the subject.
Okay. Okay, good. But like the point is that right now, 4 is being added to you, right? But you don't want 4 added to
Yeah,
you.
4 plus U.
Do you want 4 being added to you, or you just want U by itself?
Yeah,
And you just want
you
U
want
by
the answer. So, yeah, you
exactly.
just want U.
So exactly here what I was saying, right? I was saying you're adding 4 to U right now. So instead of you having U
Yeah,
by itself, you have extra 4. You're adding 4 to the U. So you need
yeah,
to
and we don't want that.
exactly. So you need to get rid of the extra. You need to take away that 4 to figure out just for you alone. Yeah, it makes sense. So you're just taking away
Yeah,
4 to remain with you alone. Because you
An extra 4.
yeah, you're right. So would have just been simply equal to 6 minus 4. So u would have equal to 2. And it'll make sense because watch. Where's 2 plus 4?
6.
And where's 2 by 3?
6.
Right? And the wheel would spin. Right? They make perfect sense. Right?
Yeah.
The letters being confused actually. Is the
Yeah.
same thing, just mean we just substituting numbers.
Yeah, those letters could be any number, could represent any number in the whole world.
So
Right.
this is just put a random, say like if you let us overcomplicating it, just put some simple numbers. Just assign the letters as some simple numbers. So since you have V, you could put V equal to 1, U equal to,
And you could work it with number anyway, and you could work with the numbers, and then like he's going to say in the end, just write back the.
yeah, just write back.
That's exactly what I plan on doing.
That's fine. That's fine, right?
It's completely legal. Like,
Yeah. Yeah, because you're just trying to rationalize the problem, trying to make sense of it. It's fine. Right? But you understand that I want to find for u, so I gotta take away v. It just signs across. So
Yeah.
the u is just equal to vt minus v. So you feel like you're gonna lose these marks, you might actually have a chance of getting the marks. Tell me if you feel like you can get the marks.
Yeah, again,
These are moodiest. Well, let me look at one more example, right? And then I'm going to move on to proportionality. And then I'm going to move on to simultaneous equations. Right? Then I'll do like 2 more past paper questions on algebra. And tomorrow we'll finish relations, functions, because you'll have a good base with algebra, so we can finish that. And after that, we'll stay back and we'll decide what's the next course of action. Right? We'll also cover linear programming as well, because that comes in paper 3, and we'll look at some paper 3 questions. Right? Okay. So, Faith, I want you to unmute and let's look at this question together, right? So we have y is equal to x plus 3 all over 2, right?
okay.
And I want you to make x the subject. Make x the subject.
All right.
So first things
So we put the y and the x plus 3 over 2 here again, right? That's not what they do before? Yeah, that's what they do. And then they cross multiply.
right? So I write y over 1. Y over 1,
Yeah.
right, is equal to x plus 3 over 2. Then I cross multiply. Yeah?
Yeah. So y plus 2.
Nah. When you cross multiply,
No?
you're multiplying, not adding. You say y plus 2. You're multiplying. You're multiplying.
Okay. So y2.
2y. Y2. Same thing, but right?
2y.
Right? 2y. But let me just say something, right? You want to make x the subject, right?
Yeah.
If you make something the subject, usually it's on what side? The left-hand side or the right-hand side?
The left-hand side.
So here what I would advise you. If you want to find for x, do that multiplication first. So it'll be on the left-hand side. So it's 1 by x plus 3.
So 3x.
Nah. What is 1 by anything? Like if I ask you, it's 1 by 5. Look at something.
Itself.
Right. So this wouldn't be 3x. That's x plus 3, not 3x.
Okay, well, it's set more up there, but tell me I can't put the y in front of the 2. But it's okay. So x plus 3
Right?
is equal to 2y.
Yeah. Right?
Oh, okay. So the plus sign, I don't think I have to go on this side. All right.
So like,
So
because I'm curious.
we want to make the x the subject. So I'm gonna move that 3 over the number line.
Right?
So it'd be x equals 2y minus 3.
That's all? That's it? That's it?
Yeah. Yeah.
But where you getting 3x from?
From the top here.
But I don't see like it's x plus 3. And then they were saying something about a cap for the. I mean, it's you can write
Yeah,
more than 2 here.
when I did say y2, you say it's better to put the 2y.
Right.
So that's why when you the same thing I say 3x.
Oh, you was thinking that
When you ask
nah,
1, yeah.
nah.
Yeah.
When we multiplying, right? It's y multiplied by 2, right? So you were saying y2, which is fine, right? That means y by 2. But the most standard thing to say is 2 times y, 2y, right?
Yeah.
And over here, it's 1 multiplied by this entire thing. So 1 by anything is itself.
1 by x plus 1 by 3.
Yeah, 1 by x is x, 1 by 3 is 3. So x just x plus 3. Or even better way to think about it. What is 1 by, I'm going to ask you a bunch of questions, right? 1 by 9 is?
9.
1 by 5 is?
5.
So 1 by all of this is just x plus 3. That's it. You understand?
All right. Yeah.
Okay, so you getting this marked in the exam?
Yes, definitely.
Okay, good. You see how it's important to not just say on accept the L and just move on. Don't think like that. Right? That's illegal. You will not make it verify if you think like that. I mean real. You just have to accept the struggle and just keep trying.
So at that point, the cross multiplication way actually really seems very much easier to do.
It is, yeah, because like whole lot today we was doing that, right? Whole lot today
Yeah.
Good. Right? Okay, let's move on to proportionality now. This is an area that is like tie up real people. First of all, do you know what proportionality is, guys? Yes or no?
No.
Nope.
All right. Let me give you an example, right? Oh, you know where's that spring? Like for a pen or something.
Yes, sir.
Okay. I'm gonna give you that physics example, right? So this example says force is directly proportional to extension. So if you have a spring, right? Any more force you apply to it, the greater the spring will stretch.
Yes, sir.
Wait, that makes sense. Like if you have a spring and the more force you apply to it, then they would stretch more, it would extend more.
Yeah.
So I would say force is directly proportional to extension. The more force I apply, the greater the extension is going to be. Simple example. Everybody understand that?
Yes, sir.
Yes, sir.
But guys, will all springs be the same
Repeat that
stiffness?
again.
Okay. Wait, let me go like actual. Do I have a pen? No, I don't have a pen, but Faith, if you have a spring, right? And the more force you apply to it, the greater it's gonna extend.
Yeah.
Right. So I would say
Oh, I
force.
thought you were talking more that other spring. Sorry.
Oh no, I'm saying force is directly proportional
Yeah.
to extension. So when I increase my force, what also increases?
The length of the spring.
The extension length, same thing, right? Cool.
Yeah.
So you understand that. That's what proportional means. If you increase one, the other one increasing. That's all. Right?
Okay.
But it's gonna increase at a specific rate. Guys, will all springs have the same stiffness?
No, sir.
No.
No, those who doing physics here, they would like no talk about Hooke's law and what.
With hooks, law and thing.
Yeah.
Okay.
So guys, all you should think about it. The spring for a pen in a pencil case, would that have the same stiffness as the spring for a car?
No, sir.
So we need to introduce something else. So what I'm saying is, different springs might have different stiffnesses, right? So if you apply a certain force, it mightn't extend the same. That makes sense, guys?
Yes, sir.
How about the rest of you guys? Are saying that not all the springs have the same level of stiffness. So maybe if you apply a certain force for one spring, it might break the spring. But for the other one, the spring mightn't even move. So right after this, so I'm saying force is proportional to extension. It means that if force increases, extension increases. So the next line, I would say that force is equal to some constant of proportionality by extension. And let me explain. Let me just say the spring real stiff, right? Real stiff. This, yeah. Guys, if the spring real stiff, if you apply plenty force, you think you're gonna extend much? Like, okay, for serious, you think you're real strong?
No, no, sir. I fragile.
Hey boy, damn. Right? All right, for serious. You think you could, okay, you spring from a pen, and you could easily pull that, you could extend that easily, right?
Yes, sir.
You think you could easily extend the spring for a car, like the shocks?
No, sir.
I don't even know I could do that. I might die, right? So the point I'm trying to make is, depending on what the value is here, it's going to affect how much force you had to apply and how much it's going to extend. So this is the general concept of proportionality. If one increases, the other one increases. Do we understand the general concept? Let me know, guys.
Yes, sir.
All right. People who doing physics are probably smiling. It's making extra sense for them. Come like I just teach slow, right? Proportionality. Right? If one quantity goes up, so does the other. Right? And the simplest example of this is a spring. Right? So F proportional to extension. Right? So this symbol over here means proportional. Right? F stands for force. E stands for extension. Right? And typically, you will have a constant of proportionality. And this will be called K. So my first line would look like F is proportional to E, and then I will say F is equal to KE. K will tell me how much, right? So for us, and you understand that generally speaking, the force you apply to a spring will extend it. Yeah? And Perseus?
Yes, sir.
But depending on how stiff the spring is, and that would affect how much it's going to extend.
Yes, sir.
Yeah, so you can think of this value K as what controls the proportionality. Is like it what determines how much the spring would extend or something. You understand?
Yes, sir.
Right. Now, guys, if that is proportionality, what do you think inverse proportionality is? If I said proportionality is when one quantity goes up, the other one does, what do you think inverse proportionality is?
I think and it has something
goes down?
related to do with degrees.
Um, I should have some example I could give you in physics, right? But the easiest thing I could tell you is if one goes up, the other one goes down. So for proportionality, right, if one quantity goes up, the other one goes up as well. So for example, if you apply more force on a spring, it extends more. Simple proportionality, right? Inverse proportionality. Right. If one quantity okay, let me explain. It's a good one. Right? if your procrastination going up, what kind of take grades?
God.
Right,
Will go
guys?
down.
Exactly.
Weird ways. And
So basically, so the same force being applied on it is the same force that we will be emitted from the object, sir.
Say that again.
Or methods. The same force being applied, sir, is the same force that will be emitted back, sir.
You talking in terms of physics?
Well, I'm trying to understand it. If I could apply it to this, what we're doing here now.
Okay, well, this was the example of proportionality. As I was saying that, if you pull a spring, right, it go extend. The more you pull it, the more it go extend.
Which you been talking
That's simply it.
Okay.
Yeah, like that. The resultant force. That's third law. Is you physics by chance? Tell me.
Yes, I did.
Okay. All right. So, the best example I can give you, right, is probably like if you hang mass, let's just say you hang a mass on a spring. If you push up the mass, the spring would like apply a force upwards to pull it up. So like
Yes, sir.
you would have the mass would be weighing down the spring, but
Yeah.
for the mass to stay afloat, right? To stay
Mm-hmm.
at equilibrium,
Mm-hmm.
you need to look at the force balance. So the force, it would have an upward force exerted by the spring.
Yeah, yes, sir. That was asking, sir.
So like in terms of a physics perspective, right?
Mm-hmm.
The force would be equal to KE, right?
Yes,
Where
sir.
K is the constant of proportionality or the stiffness and E is extension, right?
Okay. Yes,
And
sir.
you could potentially use this to figure out for the weight of the block. So if you could figure out the force on the spring, you could figure out the weight of the block that's attached to the spring by using KE.
Okay, sir.
Yeah, and then you could use that to find for the mass as well, because remember, weight is equal to mg.
Yes,
Right?
sir.
So that'll be W over G.
Mm-hmm.
Yeah. Right. So guys, an example of inverse proportionality. If your procrastination levels go up, what happens to your grades?
That's a diabolical example.
Gonna go down,
Right. So one going up while the other one,
goes down.
exactly. So if one quantity increases, the other drops.
Thinking of what
Uh, let me get like a good example of inverse proportionality. You know what? I will just make an example: procrastination and grades. Right? Right. So like let me just call procrastination P, right? Measured in terms of hours, and grades is in terms of a score, right? I would say that procrastination is I'm gonna write back the proportional sign, but instead of writing proportional to G, I'm going to write 1 over G, right? To signify that is inversely proportional, right? And then I would say P is equal to K by 1 over G. And that's how you would basically handle an inverse proportionality question. Yeah. So if it's proportional, right, you just put the two quantities proportional to each other, and after the equal sign, you're going to multiply by K. K is the constant of proportionality. In terms of the example I gave you with the spring, each spring would have a different level of stiffness. So that would control the force on the extension. So that's why K is there. It's called the constant of proportionality. And it tells you how proportional two quantities are. So Faith, do you understand what I'm saying? Like, if you have a spring and the springs, some springs might be really stiff, some springs might be really easy to stretch. You understand what I'm saying?
Yeah, I understand.
And some value in the equation needs to control how proportional they are. So like, okay, if I apply a force of 5 newtons, how much is it going to stretch? That kind of thing. And for inverse proportionality, if one of the quantity increases, then the other one drops. An example is you would say P is proportional to 1 over G. Right? Notice I'm writing this as a fraction because it's inversely proportional. If it was proportional, I would have said P is proportional to just G. But because it's inversely proportional, I'll write 1 over G. And in the next line, I'll multiply it by the constant of proportionality K. So guys, take a screenshot of this, right? We're going to do a question now on proportionality. After this, we have to look at simultaneous equations. Yeah. Right? Let me know if you guys have a screenshot.
Yeah, I got it.
Right? So who wants to do this question with me? Who wants to do the question with me? It looks scary, but I promise you it's not as bad as you think. Most things in math are not. Do I have any volunteers?
So,
Right,
I mean, right?
Sure, Perseus. I like that. So Perseus, first things first. They're saying that what? You read the question for me. You read the question.
Given that y is inversely proportional to open bracket x minus 2 close bracket and x equals 11 when y equals 9, find the value of y when x equals 29.
Who here find that sound like gibberish? Raise your hand, everyone.
It sounds like German and everything in one.
All right. So guys, look at the example I gave you here, right? I said procrastination and grades is inversely proportional, right? So I said P is proportional to 1 over G. Right, Perseus? I said that right there. So over here, they're saying what? They're saying what? What is inversely proportional?
Y?
Right. So we're going to say Y. I'm going to write the proportional sign. And instead of writing X minus 2, right, I'm going to write 1 all over what?
1 all over 2.
Nah, X minus 2.
Minus 2.
Right.
Correct.
Guys, do you understand what I was saying? Like I was saying, if something is inversely proportional, you are not going to write it as is. You're going to write it as a fraction, 1 over that, to show that it's inversely proportional. Yeah or no? Let me know what's going on, guys.
Yes, sir.
All right. And the next line, they're going to replace the proportional sign with an equal sign, right? And they're going to multiply that by key. So key multiply by 1 over x minus 2. So long story short, you can just write k all over x minus 2. Because guys, what is k by 1? What is k by 1?
K.
Exactly, right? So guys, do I know what the constant of proportionality is right now? Yes or no? Yes or no?
No, sir.
Nah. Why do you think they gave us this information? Check that Perseus. Why do you think they gave us that information? They gave us that information such that we could actually find for key. So what are they saying there, Perseus?
You want to underline, sir, where x equals 11 and y equals 9?
Yeah. So they're saying x is equal to 11 and y is equal to?
Equal to 9.
Right. So I actually need to find for key before I could find for anything else. So what is y?
Y is 9.
Right? K is what? We don't know what k is, right? Leave that blank. Right? What is 11? God, what is x?
X. X is 11.
Right? Okay. What is 11 minus 2?
11 minus 2 is 9.
Right. So Perseus, right now I have k over 9. But I want to find for k. Right now, k is being what?
K is being
So k is over 9. If something is over something, it's being what? That's what D.
divided
Right, k is being divided by.
by 9.
So if I want to get rid of the divide by 9, I have to do what's the opposite of divide by 9?
Multiply.
Right? Or you could just cross multiply, right? I could write 9 as 9 over.
1.
Right? I feel like I'll just stick to cross multiplication. I feel like everybody done on this one. Right? So process, I would say 1 by
1 by K is K.
9 by 9 is
9 by 9 is 81.
right. So that's key. So hear what, guys?
Yeah, we need
Oh,
to.
wait. That is how
Say that again.
you get the answer. So, oh,
Yeah.
it's
No, we have finished that, right? So
okay.
guys, at the start, they told us y was inversely proportional to x minus 2. So that was this line. And in the next line, you need to replace the proportional sign for equal sign and slap on a key. And then with these kind of questions, you typically need to find for k next. So they gave us the information for x and they gave us information for y. I plugged that in and I found for k. So we know that k is equal to 81. Right? So now I could go ahead and write my full equation. So what would be my full equation now, since I know what k is? What would be?
Y equals 81 over x minus 2.
Right, so we're going to use this equation to figure everything out, right? So Perseus, what did they ask us at the end?
Find the value of y when x is 29.
Right, do we have an equation for y now?
Yes, sir.
Right, we do. So y would be equal to what? You tell me what to write.
Well, 81 over x minus 2.
Yeah, but what we know x is,
X is 29, so it will be 29 minus 2.
right? 29 minus 2 is
29 minus 2 is 27.
27 into 81 is?
Ah, geez, what I did for this.
Nah, you don't need a calculator for that.
Wait, divided, right, sir?
Yeah,
3, sir.
right, 3. So let me just run out a pretty general procedure for these types of questions, right? Number 1, you need to write the proportional notation. So proportional notation. So proportional relationship. So that's what this sign. Next sign. Replace with equal and add in key. Step 3. Find for key. Step number 4. Find for anything they might be asking for. Find for anything they might be asking for. Okay, let me know if you're all like reasonably okay with the concept here.
Yes,
So,
I get it.
I want to do another question like this. Just so like lock the team. Or like, let me know.
Yes, sir. I don't mind.
What about the rest of you guys? Well, I feel like I need to do another question like this to lock the team.
Yes, I don't mind.
Yeah.
So you'll be sending notes in the group chat, right?
Yes. Right. Okay. Let me just get out that question. Right. Feet, you there? I wonder if it had anything here that I did that like blow your mind, like you don't understand at all. Like it's crazy.
It's illegal.
I think I got the general idea.
I think you have it.
I might need to see one more example, but I cannot absorb that information right now.
But let's look at one more example, right? Stay unmuted. I run try example, right? Example. Like I really don't know how people let's just have a math crash course for like 2 hours. It's like, what do you learn? What do you learn? I have no idea. Like I especially struggle to do a crash course in like a small period of time, especially for maths. Maths is crazy. The amount of content you have to stuff in, like, nah, it's crazy. Nah, but like still, even if you want answers, you can't finish your whole syllabus in that time. That's ridiculous. And $400 and things crazy.
That's the report that we pull on some of them stuff. Yeah.
So I'm gonna say, so Faith, I'm gonna say a quantity. So a quantity y varies directly, right? As the square of x. Right? Write down an equation connecting y and x using a constant of proportionality key. Right, so Faith, let me try to understand what the heck going on here, right? So first things first,
Yeah.
first things first, right? Is this direct proportionality or inverse proportionality? Just by reading the question, what do we
Direct.
direct, right? Direct. So am I going to write 1 over the quantity or just put the quantity?
We just put the quantity.
Exactly, just put the quantity. So they're saying y is proportional to,
X squared.
right? That's what they're saying, right? So the next time I'm going to say y is equal to,
X squared?
not so fast, remember. Remember the example I gave you with the spring? Not all springs going to be the same stiffness. You need to put in a constant to express that. So that's key.
Okay.
So you're gonna stop on a k here. So y is equal to kx,
Oh, okay.
right? So that k will kind of link how proportional y and x squared are to each other. That's what the k doing over there.
Okay.
Right. So that's that. That was easy. Right, next up, given that y is equal to 50 when x is equal to 5, find the value of t.
Yeah.
Right, so Faith, according to the
So
information,
first, I'll put down the same information again, right? Just so I have the formula down. I'll put y equals k x squared. Yeah. Well, all right. That's what I was gonna say to do. I wanted to put down the function first, not the. So since we know that x is equal to 5, I want to divide 50 by 5.
right?
No, wait,
But
sorry.
wait,
This is
you
x
gotta square,
squared.
let's square it. You gotta square it before you do that. So you
Yeah.
should be plugging everything one time. So 50, that will be equal to k, open bracket, square, right? So the next time will be what,
K 25.
right? Sorry, that's 25k.
Yeah.
And what next?
We divide in the 50 by 25.
Right. So find for 1k. Yep. So k is equal to
The 2.
yep, that's it.
Yeah.
Right? Right?
That's really easy.
I'm telling
That's
you,
really easy.
right? Like, I feel like if I have enough time until like, and I don't have to rush or anything, we could do the whole syllabus without rushing anything on like, or they could get a distinction in maths for sure. But like, time is like, against us. Like, or they could definitely get a distinction in maths. Everyone on there. So, what are you getting maths? Yeah. Ah, boy. Big up, big up. Yeah, grade 1, 2. Right. So, guys, if I know what k is now, right? What's my full equation? Guys, if I know what k is, what's my full equation now?
So you put in 50 is equal to 2,
No, wait, sir. Wait.
25.
Now, they gave us this information over here so that we could have figure out what k was to like complete our equation.
Mm-hmm.
Remember something, right? Y and x, they could change. Remember, I said that whatever y is, it's proportional to x squared. So the values for y and x squared could change. For y and x could change. But k is going to remain constant because that's linking whatever y is to x squared. Understand?
Yeah.
So like, you're not going to put back 50 and 5. Those were just conditions to test to see what k was. So like, in other words, Faith, what would link 50 and 5 together when k is 2? Right? Watch. When y is 50, that'll be equal to 2, right? 5 squared, right? 50, 25 by 250, right? You see, it links it together. Without that k, without the k, right? You would just end up with 50 and 25. That's not equal. You need the k to link them to link the two quantities together. I hope you all understand that. We need the k there to link the quantities together. Without the k, wouldn't make any sense. So our equation is now y is equal to 2x squared. You guys understand that? Perseus, you understand that?
So to be honest, I actually saw it.
Okay, nice. Nice. You need that break. Your eyes working good now.
Just took some eye drops.
How to get some of the eye drops, boy? Right? Yeah, so Perseus, do you want me to find the value of y now when x is?
When x is 8.
How am I going to do that?
So it will be y equals 2, open bracket, 8 squared, close bracket.
Okay, Perseus, I find it really improved. Like, I'll be honest. Like, I find like, like from where it starts off, like, yeah. What is 8 squared?
64, sir.
And what is 2 by 64?
2 by 64, 128.
Right, that's your answer. That was easy or hard?
That was not complicated. At least I won't go bald.
That's good. Now, I'm going to throw in a question here that got confused earlier. Right? Find. And by the way, I use ChatGPT to get all of these questions. I say yes, it does work for maths. It's just that you need to have some pre-existing knowledge to be able to properly use it. Otherwise, it might confuse you. Might. So let me see what they're going to do here now. Aaron, is still there? Aaron, is still here?
Yeah, sir.
Oh, a surprise. Big up you, Aaron. Right? So, Aaron, let me see how bad it is, right? In part D. They want me to find the value of what?
Find the value of x when y is equal to 18.
First things first, what's the equation we came up with? Check the screen and tell me what equation we come up with. It's not like I wake you up from sleep day.
I was feeling kind of drowsy, sir.
No. Everybody feeling kind of drowsy. I'm gonna lie. Feeling kind of sleepy. So that's why I'm gonna
Y is equal to 128.
Nah, that wasn't that's our answer. That's not equation.
Oh.
Right? Check it out.
So y is equal to 2x squared.
Right. And they want me to find the value of x when y is 18. Right? So what we know there, you know that what? Y is
18. So
So
it'll be 18 is equal to 2x squared.
right? And then I'm gonna do what?
You're going to put the 2 on the other side. Oh, sorry. You divide by 2, sorry.
Okay, fine. If you move it on the other side, you just divide, it's fine. And you're gonna end up with x squared is equal to
9.
right?
But you'll need to make the x by itself, so it'll be the square root of x. You have square root in both sides. So it'll be x is equal to 3. So
Notice it said value. If they said values, you would say plus or minus 9, right?
yeah.
Good. If they say values, please put plus or minus 9. You'll lose a mark if you don't put plus or minus 9.
Okay.
So x would just be equal to 3. We okay with this?
Yeah, sir.
Right, last question. And so state whether y increases or decreases right. So Aaron, first things first, this relationship was a what? Kind of relationship this was? Directly proportional or inversely proportional?
Inverse proportional.
I read that back from. It varies how?
Varies directly as the square of x.
Directly, right? So if something varies directly, when one increases the other one, so directly means that if one increases, the other one will increase as well. So do you think why would it increase or decrease if I half x, if I make x smaller?
I think it would decrease it.
It would decrease, right? Because this relationship here is a directly proportional one.
Yeah.
It means that if y increases, x increases. Therefore, if x is halved, let me see if I can figure this out, right? So we came up to process and we came up with y is equal to 2x squared as the equation.
Yes, sir.
To process, if I half x, right? Let me show you what happened. So instead of writing x, I'm gonna write half of x. And I'm gonna square that. Where's a half squared? Where's a half by a half?
It will be a quarter, sir.
Right, so 2 by a quarter, and x squared is just x squared. So if I were to half x, Y would be 2 by a quarter is what? What's 2 by a quarter?
That'll be 2 over 8, 1/8, or a half.
Yeah, because 2 by 1
Let
is
me
2 over 4 is a
multiply.
half.
I forget they could simplify it.
Yeah. Now that wouldn't be it, eh? Because watch, 2 by 1 is 2, 2 over 4, right? So
Yeah.
it was asking us to state whether y increases or decreases when x is halved. So we know we're dealing with a directly proportional, right? Directly proportional relationship. So we know that if one increases, the other one increases. If one drops, the other one drops. So if x is halved, so you see that here, if x is halved, right, y gets halved as well. So if it's halved as well, then it decreases. And where's my proof? This is my proof. What do you feel about proportionality? We just look at like they could bring a question exactly like how I brought it here in the exam.
You're making me think of this functions.
Hey, here what? All of this is functions, eh? All of this is functions. All of this is functions. All of this is algebra and functions. All of this. Every single thing you see in here is algebra and functions. So when we're doing functions tomorrow, I hope that we speed through it. Right. So guys, are you okay with proportionality by chance? Like, what do you think about it? Hard, easy? We just finished proportionality.
Normal, calm, feeling confident.
That's good. That's good.
Yeah, that's it.
Right. So for algebra, oh, we have finished yet, eh? Oh, we did? Oh, yeah, we did. We finished proportionality. So we looked at the inverse proportionality question, and we looked at a proportionality question. So the only thing we have to look at next in algebra is simultaneous equations. Before I leave, I just want to do some, like 2 simultaneous equation questions with you all to show you guys how easy it is. Because really, it's really not that hard. I promise.
So, sir, if I get through that worksheet, I should be good with all of these things, right?
Functions worksheet, yeah, you should be good with function. Nothing CXE could bring should it should affect you.
All right,
Right?
sir.
And if you could do this functions worksheet real good, like you're real good, like you're real good, you're set for like you're more than set. Like, okay, if you could do this, functions is an easy thing for you. Relations, functions, algebra, easy for you, right? This is like a really good worksheet, a really, really good worksheet, right? And you had to appreciate the memes, pick up the memes, right? I will send the algebra one as well, right? And yeah, I'll send the simultaneous equation worksheet as well.
So
Yeah.
you could just send me the worksheets I have, like
All
for each
okay.
topic. Yeah.
I just sent all right. I just sent all of
Yeah.
them. Yeah, just send all. Let me go through simultaneous equations quickly before we end the night, right? So we could say we finish with algebra. Now, the method that I'm going to employ here is elimination. I think elimination is much more simpler than substitution. But by all means, if all you want me to show a substitution, like in detail, I don't mind. But like I just saying, elimination, especially for maths, is the smarter move to make. You'll really have to use substitution. But even like in regular maths, when you have to use substitution, then they're not that easy. Right? Sometimes they might give you a question, they're gonna be like x plus y is equal to 9, and then they might tell you y is equal to x plus 3. Like from there, you just replace y with x plus 3 and you go about it there and you find the x. Simple. Like real easy. All right. If you do not maths, however, RIP. Yeah, it's a lot more harder. All right. So just some hacks for simultaneous equation. So when you're doing the elimination method, right? When you're doing the elimination method, you want to cancel off one of the unknowns. So elimination, right? So elimination means that you're going to cancel off one of the unknowns. Now, if what you're trying to get rid of has the same coefficient, now when I say same coefficient, let me give you an example. Let me just say you had something like 9x, right? 9x and 9x. Guys, if you wanted to cancel that, what would you do? Would you add it? Would you minus it? What would you do? Add 9x and
Divide, sir.
you said multiply?
No, I said divide.
No, not divide, minus. What's
Oh.
9x? If you say 9x divided by 9x, you'll get 1, right? If you minus, what you'll get? What's 9x minus 9x?
0.
Right. So if you have the same coefficients, example 9x and 9x, right? I just put 9x and 9x. You subtract. Right? And y? The question is, what is 9x minus 9x? 0. If you have the opposite coefficients, example, let's just say you have 9x, right? And you have minus 9x. What do you think you're going to do? You think I should add or subtract? If I have 9x and minus 9x, what do you think I should do? You think I should combine them, minus them? Do I have any volunteers? Does anybody know? Everybody's really, really quiet. Like really, really quiet.
You add them, sir. You add them.
Yeah, you add them, you combine them, right? Because there's the opposite. They are the opposites. You cancel off. Right? So you right, and y again. Guys, what is 9x minus, okay, what is 9x? Tell me, right? What is 9x plus minus 9x? What do you all think?
0, sir.
Exactly. And then the goal here is to get rid of the unknown.
Yeah.
Exactly, right? All right, cool. So if you see the same coefficient, subtract. See the opposite one, you add. That's it. So in this example, I make this one real simple, right? Real simple. What do I think we should do? Like if I'm looking at x, right? Is x the same? Tell me, is it the same?
Yeah.
If it's the same, we should do what? Same, do what?
Minus.
Minus. What is x minus x?
0.
Right? What is, be careful with this, right? So we have y, right? Y minus minus y. So y minus minus y.
That's 2y, sir.
If you're confused, watch. Minus by minus y is plus y. Y plus y is 2y, like Aaron said. So this is going to be plus 2y, right? And then we have 10 minus 4. What is 10 minus 4?
6, sir. So, yeah.
What is 2? If 2y is equal to 6, right? Or y will be equal to what by 2 is 6?
3, sir.
I say answer one time, right? It's easy, man. Easy. The long working will be to divide both sides by 2. So y will be equal to 3. Guys, was that hard? No, right. That wasn't hard. And to find for x, what are you going to do? Tell me, guys. So, guys, don't we have two equations that have x and y in them? Yes or no?
Yeah.
So we can use any one, right? So plug into any one of the equations, right? And find for x. And if you don't believe me, we're going to check it out now. So guys, what am I? So let me use the first one, right? Let me just call this the first equation. And let me call this the second equation. Why not? Let me plug it into the first one. So I'm saying y is 3. So anywhere I see y, what am I going to write instead? If we know y is
3.
So let me use equation 1, right? So x plus y is equal to 10, right?
Mm-hmm.
So we know y is 3. So I'll say x plus 3 is equal to 10.
10.
If I want to find for x, I'll take the 3 and I'll move it across. So x is equal to?
10 minus 3, so
Yeah, we're still minus 3,
7.
right? Bam. Get my answer one time. Right? Let me try using equation 2 now. Equation 2 says x minus y is equal to 4. X minus y is equal to 4. Right? What? Yeah, x minus y is equal to 4. What do we find y to be?
3.
So x minus 3 is equal to 4, right? I'll take minus 3 and I'll move it across. So that minus 3 will turn to what?
Positive 3.
It's 4 plus 3.
7.
Yeah. Doesn't matter how you do it. If you do it and it makes sense, you get the correct answer, right? So that was that. Let's look at the second example and then we'll call it a night. Right. So guys, in this example, things are a bit more crazy, right? If you look at this directly, if you just by looking at this, are the coefficients the same? Over here I have 2, over here I have 1. Are they the same?
No, sir.
No. Over here, are they the same?
No, sir.
So here what we could do, right? Here what we could do. Can we both agree? Okay, Aaron, what do you want to get rid of? Tell me what you want to get rid of first.
I guess the x and y, the 2 and 3, sir.
No, wait, you had to get rid of one unknown at a time. One unknown at a time. So you want to get rid of x or y?
X, sir.
X. So here we're going to do, right? So you see how we have 2x over here?
Yeah.
I could multiply this entire thing by, what do you think?
2x?
No, 2.
Oh,
Share why I'm saying that. If I multiply this entire thing by 2, right? What is it going to turn to?
2x plus 2y is equal to 2.
Right. Right? 2x plus 2y is equal to 2. Okay. So I could call this equation 1, call this equation 2, call this equation 3. So what am I going to do, right? I'm going to take equation 1, right, which is 2x plus 3y is equal to 18. And I'm going to minus that from the new equation, which is 2x plus 2y is equal to 2. Do you think you understand? Wait, I'll say the answer one time. Do you think you understood why I multiplied equation 2 by 2?
Yeah, sir. So you could get an equation with the same coefficient.
Exactly. Where's 2x minus 2x?
0.
What is 3y minus 2y?
1, sir.
18 minus 2?
16.
Right, y is equal to 16. We get the answer already. Nice. All right, cool. If y is equal to 16, how am I going to find for x?
Anywhere that it has a y, you have to put in the 16.
Exactly. Which equation do you want to pick? It don't matter. You can pick 1, 2, or 3, anything.
Equation 2, sir.
All right. Right. Equation 2 says x plus y is equal to 1. So where's y?
16.
I want to find for x. So why do we do 16?
Carry it over on the other side.
Right? So that positive 16 going to turn to what?
Negative 16.
1 minus 16 is?
Huh?
1 minus 16 is?
Negative 15.
Right. And if I still don't believe me, watch. Let me use equation 1 now. Here, and we're supposed to get the same answer.
Yeah.
Right? So equation 1 says 2x plus 3y is equal to 18. So again, in this case, y is 16. So I'm replacing y with 16. So I write back 2x, and what is 3 by 16?
3 by 16 is 48.
Right? So we end up with 48 is equal to 18. We'll have to move across the 48. And when you move across the 48, that's going to turn to what?
Negative 48.
Right? So you're going to end up with 18 minus 48, which works out to be what? Minus what?
Minus 30.
Ah. And to find for 1x, you can divide both sides by 2.
Mm-hmm.
And there we go.
And you'll get negative 15.
It really don't matter, right? It really doesn't matter which one you pick. Yeah. So guys, today we covered the entirety of trigonometry, right? Today we looked at all our algebra. So tomorrow, right? So I'll send all my worksheets tonight, however resources I could send. And I'll be organized for tomorrow one time. Right? So we are done with geometry and trigonometry, right? We are done with algebra. Tomorrow, relations, functions, and graphs. And what else? Pick your poison, guys. What do you want to do after relations, functions, and graphs?
Vectors.
So
Yes.
Let me hear.
Vectors.
I hear plenty people saying vectors.
Slow you on statistics, let you do something a little easier and then we can do the vectors.
Yeah, I want to do statistics.
Yeah.
think
Hey,
so.
what? Tomorrow we can start off with statistics. Are real easy. Right? It's real easy. Okay, so I'm just running the plan for tomorrow. So the plan for tomorrow. I want to finish this, right? Let's finish this. Relations, functions, and graphs. It looks hard, but it's easy maths. Then statistics. I only hear one man for statistics, though. That's the thing.
I say statistics too.
Me too, sir.
Okay.
No, Lord.
All
Me
right.
too.
Yeah.
So cool. Right?
Wait, we doing the same thing tomorrow, or it's just 5 hours?
Probably the same thing tomorrow.
Okay.
Right? Because I don't believe in this Russian thing, right? I will take
Mhm.
time with Olive. I'll go ask one of the questions. I will work with you and we will make sure we get that one, right? So we will take the time. So yeah, plan for tomorrow, relations, functions, and graphs. I'm gonna send out the worksheet and statistics. That's an easy one. That's a brain cooler. It's like a no-brainer. And well, the last
Yeah,
day,
we're not on topic.
yeah, and the last day we can look at section 1, 2, and 3. This 1, 2, and 4, right? It's usually very easy, right? And tomorrow I'll see if we could do vectors and matrices as well. We will see, right? But like I was saying, right? Relations, functions, and graph is easy max. I could count on my fingers the things you need to know for that. It's real simple.
Okay, sir.
You need to know how to input something into a function and get the output. You need to know how to find the inverse function. You need to know composite functions. You need to know how to graph a function. Yeah, real simple, right? You need to find the y-intercept. the maximum minimum for a quadratic curve, maybe completing the square. I'll check with the syllabus, but that's it. So yeah, guys, I'll see you all tomorrow. Later, everybody. Bye-bye.
Bye, sir.
Good night.
Bye.
Night, sir.
Bye.
Night, sir.
Bye.